In this video, we'll describe logging architecture of Kubernetes cluster and different types of logs maintained in Kubernetes cluster. And that we will do using a diagram which is currently displayed on the screen. On the screen, we have a Kubernetes cluster which has multiple nodes. For now, we can see two nodes which are there at the left for illustration. Every node will run multiple containers, and each container will be within a particular pod. When you write your microservice application, it is composed up of all the containers across the cluster, where every container will produce its own output, which is automatically collected by Kubernetes and it is stored in the node. And that's what is reflected. These outputs are then submitted to log aggregation subsystem, which will merge the log files and then forward the output to an external log collector. And this log collector will be a centralized location from where you can do analysis using various different analytical tools to understand what's happening inside components of cluster. Now we can classify types of Kubernetes logs into three categories. First, Kubernetes container logging, which contains logs which are generated by containerized applications. Second is Kubernetes node logging, where everything that a containerized application writes to stdout or stderr is streamed by container image to a logging driver. And these logs are usually located in the /var/log/containers directory on your node. Third type of log is Kubernetes cluster logging, which refers to Kubernetes itself and all of its system components logs. We can differentiate between components that runs in container and components that do not run in container. We need to also understand that each component will have its own role. So you need to ensure that you are able to give insight into the health of your Kubernetes server by using Kubernetes cluster logs. Now we'll also discuss Kubernetes logging best practices. As an administrator, we need to set up appropriate logging system. We need to also identify log retention mechanism. Third, it is considered good practice to write logs to stdout and stderr. Apart from that, it is suggested to use separate clusters for development and production. And finally, avoid using Sidecar container for logging. With these best practices, you'll be able to set up your logging mechanism on Kubernetes cluster properly. Now let's try to list certain tools which can be used for Kubernetes logging. First is Sematex, which is compatible with large number of log shippers, which includes Filebeat, Logstash, as well as FluentD. Second is FluentD itself, which is an open source log aggregator that allows to collect logs from Kubernetes cluster, then takes responsibility of parsing them into various different formats and then ship them to desired location. Now third is ELK. Now ELK stack is by now the most popular free and open source log management solution. It's collection of various tools that ensures an end-to-end logging pipeline. And finally, Google Stack Driver. It's a free Kubernetes native logging and monitoring solution used typically for applications that are running on Google Cloud Platform and Amazon Web Services. So after identifying logging architecture of Kubernetes, you need to select the right tool and apply best practices to maintain logs. In this video, we'll create a manifest file and use kubectl command that configures pod specification with a container that writes some log to standard output once per 5 seconds. Let's go ahead and write a manifest file. To write a manifest file, we'll be using VI editor. To invoke VI editor, we'll write VI followed by space name of the file. Once editor is launched, we'll move to insert mode and we'll write few lines of configuration that results in running one container that logs to stdout every 5 seconds. To do that, we have specified API version to be v1 followed by kind, which is pod, followed by metadata. We are giving a name to the pod, which is pod sample, followed by spec,
followed by containers. We are giving name to the container. Name we are giving as pod sample, followed by image that we want, followed by arguments, where we are moving to bin sh, which is the first argument within square brackets, followed by comma, followed by dash t, comma, and then we are writing the logging statement, which is while true, semicolon, followed by space do space echo space the date. And to specify the date, we are using dollar within brackets date. We are placing a semicolon and then we are writing the statement to create the delay of 5 seconds. To do that, we are writing sleep 5 followed by semicolon followed by done, and we are closing the square brackets. Once we have written the configuration file, we'll save and we'll exit. To save and exit, we'll press escape followed by colon WQ. Now we are out of configuration file. Let's go ahead and apply the manifest in order to create the desired pod, which has a container that logs every 5 seconds. To do that, we'll write kubectl followed by space apply followed by space dash f followed by space name of the file, which is c15 underscore v3.yml. After writing name of the file, we'll press enter. Once we'll press enter, we'll find that it has created the pod. Let's go and see whether pod is created or not and what is the current status. To do that, we'll write kubectl followed by space get followed by space pod followed by space name of the pod, which is pod sample. After writing name of the pod, we'll press enter and we'll find that pod is in running state. Now let's go ahead and look at the log for this container. Name of the container is pod sample itself. So we'll write kubectl followed by space logs followed by space pod sample. We'll press enter. Once you'll press enter, you'll find the log entries which are currently made. Now this particular command will call kubelet service on the node to retrieve the logs. Now we can see the logs are collected and they are presented with Kubernetes. This will be done for each container in a pod across your cluster. We are using kubectl to retrieve logs which are saved in individual nodes in the cluster. And in the current scenario, it will log every 5 seconds. We'll run it once again and press enter. You'll find that number of log entries are increasing. This is how you'll be able to create a manifest file and use kubectl command that configures pod specification with a container that writes some logs to standard output once per 5 seconds. In this video, we'll demonstrate use of kubectl command using various flags that returns snapshot logs from pod with the single or multi containers and snapshot logs from all containers in pod defined by label. Now let's start by getting all the pods which are currently running in the cluster. To do that, we'll write kubectl followed by space get followed by space pods. We'll press enter. Once we'll press enter, you'll find existing pods in the system. Once we get existing pods in the system, our objective is to return snapshot logs from a particular pod which has only one container. We'll write command that starts with kubectl followed by space logs followed by space name of the pod. We are using pod sample. After writing the name of the pod, we'll press enter. Once you'll press enter, you'll be able to see snapshot logs which are being collected from pod named pod samples. Now, in case if we want to return snapshot logs from pod with multi-containers, to do that, first we'll clear the screen. We'll write kubectl followed by space get followed by space pods and we'll press enter. Once we'll press enter, we'll get the pods. Now we are having nginx dash sample dash followed by alphanumeric combination. So this particular pod named nginx dash sample has two containers. Now let's go ahead and get the log. To do that, we'll write kubectl followed by space logs followed by space name of the pod. We'll be selecting a different pod which is nginx dash sample followed by alphanumeric. After writing name of the pod, we'll provide a space followed by dash dash all dash containers equal to true. After writing the command, we'll press enter. Once we'll press enter, you'll find that it gives log of all containers which are present in current pod. So whenever you want to get snapshot logs from multi containers of a pod, you can use this command. Now let's clear the screen. Now our objective is to show all logs from a pod which is written in last hour. It means you want recent logs from a particular pod. To do that, you list the pods. To list the pods, you will write kubectl space get space pods. You'll press enter. Then you will decide that you want logs from which pod. We'll be selecting pod sample for that, and we'll write kubectl followed by space logs followed by space dash dash since followed by space equal to, for 1 hour we'll write 1h, followed by space name of the pod, we'll write pod sample, and we'll press enter. Once you'll press enter, you'll find that it displays all the log entries that are made since last 1 hour. Now let's go ahead and clear the screen. After clearing the screen, now our objective is to get logs from all containers in the pod which are defined by a particular label. Let's assume label is app equal to nginx. In order to get logs from all containers in pods which are defined by a label, we'll be using a command that starts with kubectl followed by space logs followed by space dash f followed by space dash l, which indicates that you're going to use label, followed by label key, which is app, followed by equal to and the value, which is nginx, followed by space dash dash all dash containers equal to true. After writing the command, we'll press enter. Once you'll press enter, you'll find that it locates all the logs where pods are defined by a particular label. This is how you will be able to use kubectl log commands using various flags that returns snapshot log from pod with single or multi containers and snapshot log for all containers in pods which are defined by labels.
In this video, we'll describe Kubernetes architecture that helps to manage logging at the node level and cluster level logging architectures. Now, there are three essential approaches to manage logging in Kubernetes architecture. First, by applying node level logging, where agents will run on every node. Second is Sidecar container for logging. It includes a dedicated Sidecar container for logging in an application pod. Third is push logs, which logs directly to a backend from within an application. Now let's go ahead and try to understand node logging agent. One of the ways of implementing cluster level logging is by including a node level logging agent that will be made available on every node. Let's try to understand it using a diagram which is currently displayed on the screen. Assume that you have a node, and in that node you have various different pods which run application containers. Every node will have a special pod called as logging agent pod, which will contain logging agent, and that logging agent will be connected to logging backend. So whenever there is log generated, it will be log to log file.log, applying log rotate policy, and finally log agent will read the file and it will pass it on to log-file.log. So node level logging has to be encouraged because it creates only one agent per node and it does not require any changes to the application running on the node. Second approach is streaming sidecar container. Now when you use a sidecar container, you can do it in two different ways. First, sidecar container streams application logs to its own std out. Second, sidecar container runs a logging agent which is configured to pick up the logs from an application container. Let's try to understand it using a diagram. In the diagram, we have sample pod, and that sample pod has app container named app-container, which is connected to streaming container. And this is what is sidecar container stream, which contains an application in order to log to its own std out. And that is where log-file.log is present, where streaming container will log, as well as logging-agent, which is present in logging-agent-pod will be logging. Now you have set up log rotate policy on your log-file.log. Streaming container will be required in every package, and this is what is the disadvantage, because of which we prefer using node agent for logging, which will communicate with logging backend. And finally, logs from applications. Now, if the node level logging agent is not flexible enough in your current architecture, you can create Sidecar container with a separate logging agent that you have configured specifically to run with your application. In case of logs from application, you are using app-container, which implicitly creates the log and sends directly to logging backend without any streaming or node agent. This is how, depending on your architecture, you have to decide what kind of log management you would like to implement, whether it will be node level or you'll be using Sidecar container, or you will go for push logs directly from your applications to logging backend. In this video, we'll write a manifest file that configures a pod that runs a single container, and container writes to two different log files using different formats. This is one of the critical case studies because you would like your logs to be used by log aggregators. And sometimes you will be using two different log aggregators with need of different formats. Let's go ahead and see how do we configure a pod that runs a single container and container writes to two different log files using two different formats. To do that, we will create a configuration file by using vi followed by space and will specify name of the file. After opening the file, we need to write statements. Our objective is to create pods with two containers. We are writing API version, which is v1, kind is pod. Metadata to give name to the pod, we are giving name as pod v6, and then we are starting with specifications, where under spec we have specified containers. Our container's name is container v6, followed by image, which is busybox. We are using busybox image, which is available in Docker registry from where it will pull, and then we are using args. We start with /bin/sh in order to move to shell. Then we are using -c followed by greater than in order to ensure that it is the script which is executed, where we are initializing I equal to 0 and we are starting the loop. And that loop is while space true, do two activities, where first echo is writing your log in one file and second echo is writing log in different file. In the first echo, we are specifying $i colon $date within double quotes. And in the second echo, we are changing the format, where we are using within double quotes $date in brackets followed by info followed by $i. We need to ensure that we are using redirection operators, that is double greater than, in order to direct the output to appropriate log files. We are initializing it and we are sending it for sleep. Finally, we are closing the while loop by using done. Once we are done, we are using volume mounts, where we are giving a name to the volume mount followed by mount path, where path is specified as /var/log, which is the de facto location of logging, followed by volumes, and we are using volumes with a name called varlog, and type of volume that we are using is empty_dir in order to ensure that log data is not persisted. After writing the file, we'll save the file. To save the file, we'll press escape followed by :wq. Now we are out of the file. Let's go and create the object. To create the object, we'll write kubectl followed by space apply followed by space -f followed by space name of the file, which is c15_v6.yml. We'll press enter. Once you'll press enter, you'll find that it has created a pod called pod v6. Let's go and check. To do that, we'll write kubectl followed by space get followed by space pods. We'll press enter. Once you'll press enter, you'll find that it has created pod v6.
We can use commands in order to connect and look for those two log files which are created, and entries in those log files will be different. That is what is role of the current configuration that we have created. This is how you'll be able to log file from a shared volume and then redirect the log to its own std out. Finally, we can say that we have created successfully a configuration that creates a pod that runs a single container, and container writes to two different log files using different formats. In this video, we'll be creating a configuration file that creates pod that has two sidecar containers, and sidecar container tails to a particular log file from a shared volume and then redirects the logs to its own std out stream. Now, there are various different scenarios when you can use sidecar container, and that will be used with various logging agents. To use sidecar, you can adopt two approaches. First approach is sidecar container streams application to its own std out, and second is sidecar container runs a logging agent which is already configured to pick up logs from an application container. We are going to implement the first scenario, that is sidecar container streams application logs to its own std out. To do that, we need to create a configuration file. To create a configuration file, we'll be using VI editor for now by writing VI followed by space followed by name of the file where we would like to configure sidecar container. We'll press enter after writing VI followed by space name of the file, and then we'll start writing configuration file, ensuring that we are following YAML format. First two entries are common, API version, which is v1, kind is pod, metadata to give name to the pod, which is pod v7 in current case, and then we start with specification where we are specifying containers. Name we are giving to the container is container v7, image is busybox. You can use various other images which are present in Docker registry, followed by args from where all the work starts. We go to /bin/sh followed by -c, and then we start the script by giving greater than, where we are initializing I equal to 0 while true, do which is the start of the loop, followed by echo. First echo is again logging value of I by using $I colon followed by dollar within brackets date, and this entry is in double quotes. We are redirecting the output to /var/log/log1.log, followed by second echo, which is again using $date within brackets, followed by space info, followed by space $I, and it is redirecting it to /var/log/log2.log. Then we are incrementing in order to move further in the loop, and that we are doing by writing I equal to $, within double brackets, I plus 1, terminated by semicolon. We need to ensure that every line is terminated by semicolon. Followed by sleep, we are giving 1. You can give number to control the sleep duration. Finally, done. Then comes volume mounts, where we are giving name as varlog. We are specifying mount path, which is /var/log. And then we are giving name, which is log-1, followed by image, busybox, followed by args, where we are using /bin/sh as first argument with start of square bracket. After comma, we are giving -c as second argument, and then comes the third argument, which we are specifying after giving comma immediately after -c, and that statement is within single quotes. Objective is to tail from a location that is specified using a space -n plus 1, followed by space -f, and we are specifying the file name, which is /var/log/log1.log. We are specifying second volume mounts, where we are giving name, which is varlog, followed by mount path, which is /var/log, followed by the name, which is log-2. Image that we are using is busybox. This is the second sidecar container which we are specifying, followed by args, where within square brackets we are using /bin/sh, followed by comma. Second argument is -c, followed by comma, and third argument is again tail within single quotes. We are specifying tail, followed by space dash n plus 1 followed by space dash f followed by the file name with the path. We are specifying slash var slash log 2 dot log with closing single quotes and closing the square bracket. After writing the statement, we are giving volume mounts. Name of the volume mount is varlog. Mount path is slash var slash log followed by the volumes. We are giving name to the volume as varlog, which we are using in volume mounts, and type of volume that we are using is mtdir. Now let's go and create the pod with the current configuration. We'll do that by saving the file and coming out of the editor. To save the file and exit from editor, we'll press escape followed by :wq followed by enter key. Now we are out. Let's go ahead and create. To do that, we'll write kubectl followed by space apply followed by space dash f followed by space name of the file, which is c15 v7.yml. We'll press enter. Once you'll press enter, you'll find that pod v7 is created. Now let's go ahead and access the log stream. To do that, at the prompt, we'll write kubectl followed by space logs followed by space pod v7 followed by space log dash 1. After writing the command, we'll press enter. Once we'll press enter, we'll find the log from the first sidecar container. Now let's go ahead and execute the command by changing the name of the sidecar. We'll change from log-1 to log-2. It will be the same command which starts with kubectl followed by space logs followed by space pod v7 followed by space log-2. We'll press enter. Now once you'll press enter, you can see the format which is different. This is how you can create configuration file to create a pod that has two sidecar containers, and sidecar container tails to a particular log file from a shared mounted volume and then redirects the logs to their own stdout streams.
In this video, we'll recognize best practices that need to be considered to use Kubernetes logging mechanism. Kubernetes does not have its own logging mechanism. So we need to go and we need to identify critical challenges of logging in Kubernetes. First challenge is failure to collect all the critical logs. Now, when something happens wrong, pods may get deleted or they may also get recreated quickly. Now, what happens? Consequently, the log files associated with the pod or the container will also be deleted or created quickly. Second is supporting logging SLA for different namespaces. For simplicity, people usually only deploy one log agent as Kubernetes daemon set. It means one pod per Kubernetes worker node. Now, if somehow that particular pod need to be reloaded or rescheduled, it will impact all the pods living in that particular worker node. Third is multi-tenancy for namespace logging. Kubernetes workloads typically runs in shared worker VMs. Workloads from different projects are divided by namespaces. You'll find that different projects may have different preferences for logging. So when you have to log and if you don't have common standard, it may lead to misconfiguration and security compromises. And fourth challenge is handling logging from different layers. We have logs which are created at pod level, platform level, as well as container level. So you need to have complex configuration to manage logs from all these different layers. Now, after understanding these challenges, let's try to understand best practices for operating containers. First best practice is to use a native logging mechanism preferably. Second, use stateless and immutable containers. Third, avoid privileged containers. And fourth is use applications configured with monitoring systems. Now we need to also discuss Kubernetes logging best practices. First is use Sidecar only if it is needed because it creates extra overload. Second, preferably select the right log analytics tool that meets your need. Always configure control access to log using role-based access control mechanism. Fourth, adopt consistent log formats in order to make it more readable. And finally, set resource limits on daemons that are created to collect logs. And finally, let's try to understand how to implement log aggregation. There are two different ways. First, aggregation using a daemon set, which ensures that a specific pod is always running on all the cluster nodes, and this particular pod runs the agent image and is responsible for sending the logs from the node to the central server. We can see in the diagram, which is currently displayed on the screen. At the left, we have Elasticsearch, Logstash, which is connected to nodes in order to collect all the logs which are getting generated on components of those nodes. You can create a daemon set specifying Logstash. Second is to use ELK, where you will be using same mechanism, but now as the diagram on the right indicates, you are applying Logstash on pods which are running applications. You'll be collecting those application logs, sending it to Elasticsearch for storage, and use Kibana in order to create visualizations. So one of the important and essential tasks of administrator is to adopt the right logging mechanism.
In this video, we'll demonstrate how we can use kubectl commands to inspect, debug, and get logs from applications. In the previous videos of the current course, we have seen how to log in different files and formats, how to use Sidecar to log files from shared volume. Now we are going to demonstrate how to use kubectl command that helps us to inspect, debug, and get logs from the application. Now first let's gather information. To do that, we'll get the basic information about pods. To get basic information about pods, we'll write a command which we have used earlier too, that is kubectl followed by space followed by get followed by space pods. We'll press enter. Once you'll press enter, you'll find number of pods which are running and how many replicas are there, what is the current status, and what's the age. But we want more information. If we want more information that helps us in debugging, assume that we are selecting one of the pods, that is pod V6, and we want more detailed information about it. To do that, we'll write kubectl followed by space describe followed by space pod followed by name of the pod, which is pod V6. We'll press enter. Once you'll press enter, you will get better details along with all the events which were fired when this pod was getting initialized. You will also come to know what is the type, what is the reason, what is the age, from where that event is generated, and then what is the message of that event. You have various different reasons. In the current case, we can see scheduled, pulling, pulled, created, and started. All these are normal scenarios. In case if there is an issue in your pod, you will get different type of events. As an administrator, you need to evaluate the messages and then decide what need to be done. Now let's try to focus on only events of a particular pod. We know that events are namespace scoped. So let's go ahead and first try writing kubectl followed by space get followed by space events, and we'll press enter. Once you'll press enter, you will get all the events that are generated in a particular namespace. By default, it is using default namespace. Now, one of the common approach that you have to adopt while debugging is to look at the event. See when they are created. See what kind of event it is. Identify type of event. Identify type of resource which that event is pointing to. Find out the reason for transition into object's current state. Identify the source for the component reporting to this event. And also go through the message carefully because it is human readable. After getting all these details, your next objective would be to get the logs. To get the logs, at the prompt, you will write kubectl followed by space logs followed by space name of the pod. We'll write pod V6. We'll press enter. And you'll find the logs in case if they are there any for the current pod. Now let's go and check for another pod which might have generated some logs. We are using kubectl followed by space logs followed by space pod v7 will press enter. Now you see it's not giving any log because logs which are configured are at container level. So in order to ensure that we are able to get logs, we can specify pod v7 followed by space dash c followed by the container. I'll specify log dash 1 and will press enter. Once you'll press enter, you will get the logs. So be careful when you are evaluating application and system log because it gives you better understanding of what happened inside your cluster and helps you to do further debugging. This is how you can use kubectl commands to inspect, debug and get logs from applications.
In this video, we'll describe role of resource matrix pipeline and the architecture and design of the matrix server. Now let's first try to understand sources of matrix in Kubernetes. First source is node, and we can read matrix on node using node underscore exporter. Second is container matrix, which can be collected using kubelet and cAdvisor. Third is Kubernetes API server related matrix. Fourth is etcd, capable of generating various different metrics in Kubernetes. And finally, we can also configure derived matrix using kube-state-matrix. Now we'll classify matrix types and Kubernetes matrix API. There are two matrix types. First is resource matrix and second is service matrix. Similarly, you have two Kubernetes matrix API which can be used in order to manage all the metrics in Kubernetes. First, resource matrix API and second, custom matrix API. Now we need to understand what components are going to be used in order to build metric pipelines. First component is kubelet that provides node pod container resource usage information. Second is resource estimator, which runs as a daemon set and turns raw usage values collected from kubelet into resource estimates ready for use by scheduler. Third is metric server. It is mini version of Heapster that was previously used as the main monitoring solution on top of cAdvisor to collect metrics. Fourth is master metrics API. Responsibility of master metrics API is to expose the master metrics via discovery summarizer to all external clients. Finally, we have API server, which is responsible for serving the master metrics API. And finally, let's try to understand metrics pipeline implementation using a diagram. As the diagram on the screen indicates that we have resource estimator. Resource estimator will create the estimate and it will send the estimate to metrics server. Now, how do resource estimator creates the estimate? Resource estimator will use raw usage values that will be collected by kubelet in order to build estimate on basis of raw values. Apart from that, kubelet will directly send CPU and RAM usage to metrics server. All that data will be collated at metrics server and it will be sent to API server. API server will pass on that information to scheduler, HPA, and you can also use kubectl top command in order to get core metrics. This is how you will be able to decide architecture of your metrics pipeline by identifying metrics providers, metrics types, APIs, and components which are used in order to implement metrics pipeline. In this video, we'll install and use the metrics server to manage metrics for nodes and for pods in kube system namespace. Now let's first try to understand role of metrics server. Metrics server is a Kubernetes compliant cluster-wide aggregator for resource usage data. Objective is to collect metrics from the summary API exposed by kubelet on each node which is part of the current cluster. Resource usage metrics will help when you are troubleshooting certain weird resource utilization. Now, all these metrics are available in Kubernetes using metrics API. Now, let's go ahead and understand the prerequisites for metrics server. We need to understand that to deploy metric server to Kubernetes, you need to ensure that your metric server must be reachable from kube-api server. You need to also ensure kube API server is correctly configured and nodes have kubelet authorization configured to match metric server configuration. This you will do while you are setting up your cluster itself. Now let's go ahead and deploy metric server to Kubernetes. To do that, first we will download components.yml from appropriate endpoint. And to do that, we'll write wget followed by space and the location where you have components.yml of metrics-server. We'll press enter. Once you'll press enter, you'll find that it downloads components.yml. Let's go and see the content of components.yml. To do that, we'll write vi followed by components.yml and we'll press enter. Once you'll press enter, you'll find that there are multiple different Kubernetes objects which are configured. First is cluster role, followed by cluster role binding, followed by service account, followed by role binding, followed by API service, followed by service account for metric server, followed by deployment. We need to be careful when we are looking at deployment, where API version is app/v1 followed by kind, followed by metadata. We are giving a name and we are specifying the namespace where it should be. Apart from that, we are also specifying labels. Then we are specifying spec template. We are also specifying volume. We are specifying containers, which is the most important part of your metric server. We are specifying name to be metrics-server. We are pulling the image from k8s.gcr.io/metrics-server/metrics-server : version, which is v0.3.7. Image pull policy if not present, and arguments which are specified are -cert-dir and -secure-port, which is equal to 4443, followed by ports, where we are specifying name to be main port and container port is 4443. Apart from that, we are specifying security context, volume mount, and node selector. Node selector is again important. Here we are taking kubernetes.io/os to be Linux. Then comes the service, which is metric server. It has been allocated port as 443. Protocol that it is using is TCP and target port is the main dash port which is configured in the previous configuration. Apart from that, we are specifying cluster role where we are giving resources on which metric server will be applied. They are pods, nodes, node/stats, namespaces, config maps, and also verbs, which are get, list, and watch. And finally, we are specifying cluster role binding, whose name is system:/metrics-server. After going through the configuration, we'll save and we'll exit. To do that, we'll press escape followed by :WQ. Now we are out of components.yml file. We'll clear the screen. After clearing the screen, we will create all the components which are part of components.yml. To do that, we'll write kubectl followed by apply, followed by -f, followed by name of the file, which is components.yml. We'll press enter. Once we'll press enter, you'll find that it creates all the objects. You can ignore warning for now. Once all the objects are created, we'll clear the screen. To clear the screen, we'll write clear at the command prompt. Now we'll go and we'll verify that the metric server deployment is running. To do that, we'll write kubectl followed by space get, followed by space deployment, followed by space metrics-server, followed by space -n, followed by space the namespace, and namespace where it is present is kube-system. After writing the command, we'll press enter. Once you'll press enter, you'll find that it displays a message that indicates that it is ready, up to date, and is available. After getting the deployment and its status, let's go and write another command, that is kubectl followed by space get, followed by space pods, followed by space -n for namespace, followed by space kube-system, followed by space, we'll use a pipe symbol, followed by space grep, followed by space metrics. We'll press enter.
Once you'll press enter, you'll get a message that your metrics-server-alphanumeric, which is the identifier of the pod, is up and running. This confirms that metric server is installed, and you'll be able to use metric server now to manage metrics for nodes as well as pods in kube-system namespace. In this video, we'll demonstrate how to use metric server add-on and view metrics of resource usage by pods and nodes in the cluster. Once you have installed, you can verify whether Kubemetrics is installed on the node on which you are going to use metric server to get usage or not. And to do that, on the system where you have to check and verify, you'll be writing kubectl followed by space get space deployment followed by space metrics dash server followed by space dash and followed by space cube dash system. You'll press enter. Now it shows you that metrics dash server is installed. We have already demonstrated how to install metrics server on a cluster in the video titled Install and Use Metrics Server of this course. You need to also confirm that metrics server is active, and to do that, you'll write kubectl followed by space followed by get followed by API server followed by space v1 beta1 dot metrics dot k8s dot io followed by space dash o followed by space YAML. We'll press enter. You need to understand that name is not API server, but it is API service. This name you will come to know from your YML file which you have used in order to install. Let's go ahead and change from API server to API service. After changing it to API service, we'll press enter. Once you'll press enter, you will get the details which confirms that metrics server is active. Now let's go ahead and use the commands in order to ensure that we are able to verify that metrics API is able to access your resources, and that we will do by using a command provided by kubectl. But before we do that, we'll clear the screen and we'll write kubectl followed by space followed by top followed by space followed by nodes. We'll press enter. Once you'll press enter, you'll be able to see existing nodes. For now, we have only one node. Similarly, you can also use top command for pods. Let's go ahead and use by writing kubectl followed by space top followed by space pods followed by space dash a. After writing the command, we'll press enter. Once you'll press enter, it will show you all the pods which are currently running. Sometimes you may need to pull raw resource usage matrix for all nodes in the cluster. In order to do that, we'll write kubectl followed by space get followed by space dash dash raw followed by space, and we'll specify the object in double quotes. Object that we are going to access is /apis /metrics dot k8s dot io /v1 beta1. Be ready because this may change in new versions of Kubernetes, followed by /nodes. After writing, we'll give a space and we'll use a pipe symbol. After specifying pipe symbol, we'll specify JQ. After writing the command, we'll press enter. In case if JQ is not working, it means JQ is not installed. So what we'll do, we'll not use pipe space JQ and we'll press enter. Once you'll press enter, you'll be able to see raw resource usage metrics for all nodes in the cluster. Since we have only one node, we are able to see the output of that particular node. You can go and you can analyze the raw resource data in order to get more insight in that particular node. This is how you can use metric server add-on and view metrics of resource usage by pods and nodes in the cluster. In this video, we'll create a configuration file to create a pod that has one container. After creating the pod, we'll get a shell to the running container and execute commands in the shell of the container. To do that, we need to write a configuration file. And to write configuration file, we can select editor. We are using VI followed by name of the file where we want to write the configuration. Once your file opens, you will start with specifying API version, which is v1. Ensure that you are using appropriate YML format. Followed by kind, which is pod, metadata to specify the name, which is pod v13 in the current case. Followed by spec, where we are specifying 4 essential specifications. First is volumes. We are giving a name that is shared dash data. We are specifying volumes type to be mtdir so that it will not retain the value across multiple pods restarts. Then comes the containers. Containers are specified with 3 essential properties. First is the name of the container, which is container v13, followed by image, we are using nginx, followed by volume mounts, where we are giving name. Name is similar to the volume name that we have specified earlier in the spec, and it has another attribute called as mount path, where we are specifying the directory. Directory that we are using is /usr/share/nginx/html. Now we are setting 2 other property in the specifications. First, host network, we are setting to true, and DNS policy is set to default. It is one of the essential element when you want to specify DNS policies for pod. We can define DNS policies on a per pod basis. We have specified default, which indicates that the pod will inherit the same name resolution configuration from the node where that pod will run. After creating the file, we'll save the file and we'll exit from the editor. To do that, we'll press escape followed by :wq, enter. Now we are out of the editor. Let's go and create the pod. To create the pod, we'll be using kubectl followed by space apply followed by space -f followed by space name of the file. Name of the file is c15_v13.yml. After writing name of the file, we'll press enter. Once you'll press enter, you will get a message that indicates that pod is created. Now we need to ensure that pod is in right state. Let's go ahead and verify. To verify, we'll be using kubectl followed by space get followed by space pod followed by space name of the pod, which is pod v13. After writing name of the pod, we'll press enter and you'll find that your pod is running. Now let's get the shell to the running container. To get the shell to the running container, we'll be using kubectl command followed by space exec followed by space --stdin followed by space --tty followed by space name of the container. We have specified name of the container as container v13 in our configuration file. After specifying name of the container, we'll give a space and we'll write /bin/bash and we'll press enter. You need to ensure that you are writing the right command. What error we have done is we haven't given space after --. So we need to ensure that spaces are specified appropriately. After using the command in the right way, we'll press enter. Now let's clear the screen. To connect to the container of the pod, we'll write kubectl followed by space exec followed by space --stdin followed by space --tty followed by space pod v13 followed by space --. Then we'll give a space and we'll specify /bin/bash. We'll press enter. Once we'll press enter, we'll find that now we are connected to our pod. Now let's go ahead and run certain commands inside. We'll start by running ls. Once you'll write ls, you'll find various different directories which are present. You can start working in the current container. For example, if we want to run apt-get, we'll write apt-get followed by space followed by update and we'll press enter. You'll find that it updates now the container's guest operating system. You can use whatever set of commands you want to use on the pod now. Let's exit. To exit, we'll write exit. We'll press enter and you'll find that now you are back to your master node. This is how you can create configuration file to create a pod that has one container and get a shell to the running container and execute commands in the shell of the container. So in this course, we have examined how to implement logging in Kubernetes. We did so by exploring the logging architecture of a Kubernetes cluster, the different types of logs maintained in a Kubernetes cluster,
how to return snapshot logs from pods, pods with single and multi containers, and logs from all containers in pod defined by labels. The architecture of Kubernetes that helps manage logging at the node and cluster level, the best practices to consider when using the Kubernetes logging mechanism, the architecture and design of metric server, how to install and use metric server to manage metrics for nodes and pods, and how to create a pod with two sidecar containers where the sidecar containers tail a particular log file from a shared volume and redirects the log to its own std out stream. How to create a pod with one container, attach a shell to the container and execute commands in the shell of the container. In the next course, we will learn to debug pods, create audit policy, capture and print logs, and work with CRICTL and Telepresence to debug container runtimes and applications.
In this video, we'll create a manifest file that creates deployment with two pods and use kubectl command to retrieve information about each of these pods and describe status information about the containers and pods. Let's go ahead and create the manifest file first. To create the manifest file, we'll write vi followed by space followed by name of the file. After writing name of the file, we'll press enter. Once you'll press enter, it will launch the editor where you'll start writing configuration elements in YAML format in order to create two pods. To do that, first line is API version, which is set to app/v1 followed by kind, which is deployment. Then we need to give a name to our deployment. We are giving it by using metadata, and one of the properties of metadata, that is name. We are naming it as nginx-sample. Followed by spec, where we are giving selector along with match labels, and label that we are specifying is app, which is the key, and nginx, which is the value. Followed by replicas, we are specifying 2 because we want to create two pods. Then comes the template, where we are specifying metadata followed by labels, followed by the label that we have defined earlier, which is app as the key and nginx as the value. And then finally, we are specifying the spec of the container, where we are giving a name to container, that is nginx log container. We are specifying image that container need to use, it is nginx, which will be pulled from the registry. Then we are specifying resources with limits. We are specifying limits on memory to be 128 MB and CPU is 500 M. Followed by ports, which we are specifying using container port, which is set to 80. After writing the configuration file, our next step is to create the deployment using kubectl apply command. Let's go ahead and do it. First, we'll save and exit from the current editor. To do that, we'll press escape followed by :WQ. Now we are out of editor. Let's go ahead and create the deployment. To do that, we'll write kubectl followed by space apply followed by space -f followed by space name of the file, which is c16_v2.yml. After writing name of the file, we'll press enter. Once we'll press enter, we'll find that a message comes that indicates that deployment .apps/nginx-sample has been created. Now we need to check the status of the pods. To do that, we'll write kubectl followed by space get followed by space pods. We'll press enter. Once we'll press enter, we'll find that pods are in running state. Now we can retrieve other information about each of the pods, and to do that, we'll be using a command that starts with kubectl followed by space describe followed by space pod followed by space followed by name of one of the pods. Let's select the first pod and paste it immediately after pod, giving a space. After specifying name of the pod, we'll press enter. Once we'll press enter, you'll find details of the pod, where first element that it gives is the name, followed by in which namespace it is, what is priority, on what node this pod is created, start time of the pod, followed by labels which are defined, annotations which are being used, followed by what is the current status and what is the IP. Similarly, it also shows controlled by, replica set, and the container information. So if you want to know in detail status of pod and various containers which are part of it, you can use describe command. This is how you will be able to write a manifest file to create deployment with 2 pods and use kubectl commands to retrieve relevant information about each pod and also status information about the containers and the pods. In this video, we'll recall the approaches of debugging pending pods and down or unreachable nodes of a Kubernetes cluster. Now let's first explore why pod fails. There are various reasons to it. First reason is error during image pull, and it typically happens because of wrong or missing secrets or wrong or missing image. Second reason is the app runs in an error state, which is typically by missing environmental variables which are stored in config maps or secrets. Third is liveness probe failed. And finally, sometimes you may have too high resource consumption because of which pod fails. Apart from that, there are 2 other critical reasons. First, persistent volume can't be created or mounted, probably because they are there in different namespaces. And second is container image is not updated. These are also critical reasons why pod fails. Now, what all are the steps that we can take in order to debug pods? First step is always to check the current state of the pod. Second, troubleshoot and ensure pod should already be scheduled and in running state. If it is not in running state, find out the reason by looking into the logs and identifying the root cause. And third step is to ensure containers are debug ready. Once they are debug ready, then only you will be able to debug. Now, what all are the critical commands that helps to debug pods? We are listing 4 essential commands. First command is kubectl followed by space logs followed by space pod name followed by space -c followed by space name of the container. Second command is to get details of pod, and that you will get by writing command which starts with kubectl followed by space describe followed by space pod and finally followed by space pod name which you want to describe. Then comes third command, which is kubectl followed by space get followed by space pods followed by name of the pod followed by space -o followed by space yml. You will get the output in form of yml. You can go through the output and find out what is the current state of the pod. And finally, you can use kubectl space exec followed by space pod name followed by space -it followed by space sh in order to connect to the pod in order to carry out debugging. And finally, we'll be using a sequence diagram that helps us to maintain and troubleshoot pod. There are 3 participants. First is the client, second is API server, and third is kubelet, and both of them are present in Kubernetes cluster. Now let's try to understand using a diagram which is currently displayed on the screen. Client will be invoking a command called as kubectl drain by specifying the node. Objective is to evict or delete all the pods except mirror pods, which cannot be deleted through API server. Now, once that particular request is sent, it runs control or uncordon, sends a request to cordon a node to API server. In response to the command, it will invoke run cordon or uncordon, which in turn will send a request to API server called as cordon followed by the node name. In response to that request, API server will mark that particular node as unschedulable. Once it is marked unschedulable, from the client, there will be another call that will be made for get all pods of the node. In return to that, API server will return pod list. When it gets pod list, it will invoke get pods for deletion. And it will iterate by filtering mirror pods and demonset managed pods, and then it will invoke delete first pod, which will be intercepted by API server, and it will invoke that particular command to the right kubelet. Once that request is made, then we'll call delete pods, where it will invoke delete pod n. In response to that, API server, after intercepting delete pod n, will send the request to kubelet to delete the pod. This is how you'll be able to maintain and troubleshoot pods which are not responding. In this video, we'll list the common and critical issues that are associated with pods and replication controllers that requires debugging. Let's first go and classify problem domains. We can classify it into 3 critical domains. First is Kubernetes problem, which may be there because of CNI, CSI or Kubernetes API. Second is node problem, where you need to focus on kubelet, kernel and the physical network. And third problem is application related problem, where you need to look into code and the configurations. After classifying problems, let's go and identify problem resolution approaches, which will guide us to solve general problems. For example, if you are facing Kubernetes problem, you need to check control plane logs, you need to check all the events. Apart from that, you need to check important component logs. Then comes solving general problems which are associated with node. You need to check kubelet logs, then kernel logs and test physical network as well. Now, what can be better solution? There is no fixed better solution which has been still derived for Kubernetes. It is still evolving. But what we can do is, we can add debugging container without any modification. And we can do that by using kubectl followed by space debug, followed by space, specify the target pod, followed by space -c, specify the container name, followed by space --image, specify the image, and then finally give a space and use --bash. Once you do this, you will be able to get facility of ephemeral containers. As it is indicated in the diagram currently present on the screen, we have pod, which contains target container, and you are invoking create in order to create an ephemeral container that will take responsibility of debugging by associating ephemeral container to the target container, as we can see in the second diagram. And finally, once you have done the debugging, you can delete the container. This is how you can adopt much better solution in order to debug. Now, there is a very critical problem, and the problem is continuously restarting pod. Now, how do we debug it? To debug continuously restarting pod, we'll be using an approach to identify pods that are continuously restarting. And then we will find out what command failed. After identifying what command failed, we'll replace with command that do not fail while debugging that particular pod. For example, sleep. Second approach is to find out whether it is continuously restarting because of Liveness probe has failed. If so, remove Liveness configuration temporarily while you are debugging the pod. At the configuration in the right indicates, in order to send the command to sleep, we are using within the command block one essential element called touch, followed by space /tmp/healthy, followed by semicolon, and then we are giving sleep followed by 500 milliseconds. Similarly, in order to temporarily remove Liveness, we have configured it in the configuration file, which is indicated by Liveness probe section as it is indicated in the configuration diagram, where we are using exec followed by command, followed by the command called cat, followed by /tmp/healthy, and then we are specifying 2 essential attributes. First is initial delay seconds, which we are setting to 2. Second is period seconds, which we are setting to 3. This is how you will be able to manage continuously restarting pods. In this video, we'll recall the process of debugging scheduled and running pods in a Kubernetes cluster. Your pods can be in multiple different states. First is scheduled and second is running. Apart from that, you may have container creating state or other various states that may have impact over usability of pod. Now, how do we debug scheduled and running pods? We can do that by examining appropriate pod logs by using kubectl commands. Second approach is to use container exec to debug. And finally, we can debug using ephemeral debug container. Now let's go and try to understand what we do when we are examining pod logs. To examine pod logs, we can use kubectl log commands to get logs. We can also use previous flags to get previous containers log in order to understand the state. And third, we need to track all the crashed pods log and identify the root cause. Next step is to use container exec to debug. This we will do in order to ensure that we have included debugging utilities. And we need to remember that we can also use kubectl exec command inside specific container to get more details. And finally, we can debug using ephemeral debug containers. Ephemeral debug containers are critically used for interactive troubleshooting. For example, if you haven't set up exec console, you can use ephemeral debug for interactive troubleshooting. In order to do that, you'll be using kubectl alpha debug command to add ephemeral container. Be assured that your container is enabled for ephemeral containers. This is how you will be able to plan your debugging task for scheduled and running pods in Kubernetes cluster. In this video, we'll demonstrate steps to use kubectl alpha debug command to add ephemeral containers to a running pod. Now let's first try to understand what is role of ephemeral containers. Ephemeral containers are typically used when you want interactive troubleshooting, specifically when kubectl exec command is insufficient because your container might have crashed or a container image does not include debugging utilities with it. Now let's try to demonstrate how do we work with ephemeral container and use kubectl alpha debug command, for which we need to first create a pod. Now there are different ways of creating pod. For this particular video, we are going to use command that starts with kubectl followed by space run followed by space name of the pod. We are giving debug pod dash demo followed by space dash dash image equal to k8s.gcr.io slash pos:3.1, which is a container image, and this particular container image is provided by Google without any debugging utilities. It means we have to use ephemeral debugging technique. After specifying the image name, we have to give a space and specify dash dash restart equal to never. We'll press enter. Once you'll press enter, you'll find that pod is created. Now, once pod is created, you would like to attach console to ephemeral container so that you can have interactive debugging. In order to do that, you need to write another command. Command that you will write in order to attach an ephemeral container for debugging starts with kubectl followed by space alpha followed by space debug followed by space dash it followed by space followed by name of the pod to which you want to attach ephemeral container, and name of the pod is debug pod dash demo, which we created in previous step. Followed by space dash dash image, we are taking image equal to busybox followed by space dash dash target equal to value that will target the process namespace of another container. Now let's go ahead and press enter. Now in case if you get a message that ephemeral containers are disabled for this cluster, you need to enable it. To enable it, you need to make edit in certain places. Let's go ahead and make the edit, and that we will do by writing vi followed by space slash etc slash Kubernetes followed by slash manifests followed by slash kube dash API server.yml. We'll press enter. Once you'll press enter, there will be an entry that you need to make. Let's go ahead and make an entry. To make an entry, we'll come to the end of the command section. After we come to end of the command section, we'll edit it and we'll add feature dash gates.
by specifying a dash followed by a space, double dash, following YAML principles. After making the entry, that is feature dash gates equal to ephemeral containers equal to true, we'll save and we'll exit. To do that, we'll press escape followed by colon WQ and we'll press enter. Now, next file that we have to edit is kube scheduler. To do that, we'll write vi followed by the path where you have your kube scheduler. After writing name of the file with full path, we'll press enter. We'll go to command section, and again at end of the command section, we'll make an entry by specifying dash feature dash gates equal to ephemeral containers equal to true. We'll save it. To save it, we'll press escape followed by colon WQ. Once we'll press enter, we'll come out of the configuration file. Now let's go ahead and create a pod. We'll change the name of the pod to create a new pod. We change the name to debug pod-demo1. We'll keep the image similar along with restart policy to be never. We'll press enter. Once we'll press enter, you'll find that debug pod-demo1 is created. Now we'll write clear in order to clear the screen. After clearing the screen, we'll write command that starts with kubectl followed by space alpha followed by space debug followed by space dash it followed by space debug pod-demo1. We'll specify dash image equal to busybox followed by space dash target equal to the target pod for which we want ephemeral container. We'll write debug pod-demo1. We'll press enter. Once we'll press enter, it will indicate that debugging default container name to debugger-5tgx5 has started. This is how you'll be able to use the kubectl alpha debug command to add ephemeral containers to a running pod. In this video, let's describe the features and roles of Kubernetes auditing, audit policy, and the known stages of lifecycle inside the Kube API server component. Now, what critical role Kubernetes auditing plays? First role is it provides chronological set of records related to security. Second role is its capability to document set of activities that impacts various components of cluster. Kubernetes auditing is performed by Kubernetes Server API, and objective of Kubernetes auditing is to define an audit policy that determines what need to be recorded. Now let's try to understand how do we create audit policy. To create audit policy, we need to write a manifest file. First entry in that manifest should be API version followed by audit.k8s.io/v1 beta1. Kind should be policy. Then you have to specify rules, where you need to specify 3 essential parameters. First is level, which is of various types. It can be request response, it can be request, or it can be various other levels which are defined for Kubernetes audit policy. Then comes omit stages. Now, for example, you want to omit auditing of certain stages in lifecycle. That you can specify below omit stages. For example, we have specified request receive. So it will not be logged. Then comes resources, and you have to specify group of that particular resource. After configuring policy, you need to use kubectl command in order to create or apply the audit policy. Now let's go and explore various different stages. There are 4 stages. First stage is request receive. It is generated as soon as the audit handler receives the request. Second is response started. It is generated after response header are sent, but before the response body is sent. You need to understand that it is generated only for long-running requests. For example, watch. Then comes third, which is response complete. It is generated after the response body has completed. And finally, panic. These are the events generated when a panic occurs. Now we need to finally understand log levels which are defined for audit. There are 4 specific log levels. First is none. which means don't log events that matches specified rule. Second is metadata. Log request metadata, which includes requesting user, timestamp, resources, verbs, but not request or response body. Then comes the third, which is request, where it will log event metadata and request body but not response body. And finally, request response, which log event metadata, request as well as response bodies. You need to define the right audit policy depending on your logging and compliance needs. In this video, we'll demonstrate how we can create an audit policy file that helps to set up and enable policy for cluster. Objective of policy file is to specify events and stages that are generated when a request is made to Kubernetes API server. There are multiple different stages to which that request will go through. Apart from that, audit policy files also contains set of rules which are specified in policy file. You can specify a rule that matches an event set of the audit level for that particular event. So you can have different audit levels, which includes metadata, request, response request, as well as none. This guides that how actually log entry need to be created. Now let's go ahead and create a sample policy file in order to understand how do we apply policies on Kubernetes cluster. To do that, we'll connect to master and we'll write vi followed by space followed by name of the policy file, that is c16_v8.yml. We'll press enter. Now let's go ahead and understand the entries which are there in file. First line is API version, which is set to audit.ka-test.io/v1. This is mandatory field. Then comes kind, which is policy. Now we have to specify an element called as omit stages, followed by the value which is request received, which means don't generate audit events for all the requests in request received stage. So you can go ahead and you can omit those stages for which you don't want to generate audit events. Then comes the rules, where we have to specify certain rules. For example, first entry in rules is level, which is request response. Then comes the resources. We are specifying group followed by double quotes. And then we are specifying resources, which is pods. These 4 line of entry means that pod will change the log at request response level. Apart from that, resource pods does not match request to any sub-resource of pod, which is consistent with the RBAC policy. Then comes the second level, which is metadata, followed by same entries, which includes resources, group, resources, which will include now pods/log, followed by pod/status. This is to indicate that log need to be done in pod/log and pod/status at metadata level. Similarly, we have created for config map as well, which again starts with resources, where we have specified group, followed by resources, which is config maps, and resource names that we have specified is controller-leader, which means don't log request to a config map called controller-leader. This is how you can set audit policy for various different type of objects which you will be using in Kubernetes. Let's go and save the file by pressing escape followed by :wq. We'll press enter. Now we are out of the file. In order to create the object, you will be writing kubectl followed by space followed by apply followed by space -f followed by space followed by name of the file. Finally, we'll press enter. After you press enter, it will create policy which can be applied on Kubernetes cluster and its objects. In this video, we'll recognize the feature of prominent tools that can help different logging layers and the log types which are found in Kubernetes. Kubernetes does not have its own native logging mechanism. We have to depend on external tools for that. Before we start discussing about those tools, let's try to understand log aggregation system that can be applied on Kubernetes. And that we will do using a diagram which is currently displayed on the screen. You'll have Kubernetes cluster which contains various different components. every container on every node in the cluster will produce its own output, and those outputs will be sent to log aggregation subsystem. Log aggregation subsystem will collect all the logs. It will send it to log collector. Log collector will take responsibility of generating outputs which are aggregated, and they are funneled to a centralized location to enable storing, creating visualizations, as well as conducting search for log entries whenever needed. Now we'll talk about what tools can be used for log aggregation by Kubernetes. So let's go ahead and list log aggregation tools that are compliant to Kubernetes. First is ELK, which integrates natively with Kubernetes. It's a popular open source solution for collecting, storing, and analyzing Kubernetes telemetry data. Second tool is Logi. We can use Logi to aggregate the log from cluster apps. It is designed to forward all the logs from Kubernetes to an external log collector. Now let's try to understand log aggregation using Logi. We'll have Kubernetes cluster. Inside Kubernetes cluster, we need to run a daemon set of Logi. Let's try to understand it using a diagram which is currently displayed on the screen. We'll have node which will contain pods, will have containers that will run. Kubernetes will capture the output from each container on the node to a particular log file, and those log files from every container will be aggregated by a microservice of Logi that runs as a daemon set on the node. Other responsibility of the daemon set will be to send aggregated logs to log collector, and that will be done by Logi, which can forward the output to an external log collector from where we can create analytics and visualizations to understand what's happening inside the cluster. And finally, we need to also understand how ELK and Kubernetes work together. ELK is Elasticsearch, Logstash, and Kibana. Elasticsearch is the store where all the aggregated log will be stored. Logstash is the aggregator who will poll for the logs and make that log available in Elasticsearch. Kibana will read Elasticsearch database and build visualizations. We can use ELK in conjunction with various other monitoring tools. For example, let's try to understand using a diagram which is currently displayed on the screen. At the left-hand side, we have multi-cloud, which is AWS, Azure, Google, bare metal VMware as well. There are various components, network, compute, storage, and you have various network management components which are part of logging mechanism. It has HA components, encryption, replication, as well as disaster recovery. On top of that, we are having CSI. And on top of CSI, we'll have cloud native execution runtime. Your CSI will be powered by CNI, which will communicate with the network, which is getting provisioned on multi-cloud environments in the current case. Then comes the role of Kubernetes. It will take responsibility of orchestration. It will do that by curating master nodes, data nodes, and curator. Curator will provide all the inputs which will be used by Kubernetes in order to orchestrate containers. And all this will be monitored by Prometheus, which is a monitoring tool. Prometheus is connected to ELK stack, which reads monitoring data, populates it in Elasticsearch, and makes it available for Kibana to create visualization for analytics. This is how you can use ELK and Kubernetes, but yes, there are two essential features that you need to understand. First, it can run on any infrastructure. Second, you need to select portable cloud stack that can be integrated with ELK. So depending on your need, you can select the right tool that takes responsibility of collecting the log, aggregating the log, and helping you to gain inside the log by using various different algorithms. In this video, we'll write configuration file that captures containers log using stdout and stderr. Now let's write a configuration file that captures containers log using stdout and stderr. To do that, we'll write a file using vi editor. For that, we'll write vi followed by space name of the file. After specifying name of the file, we'll press enter and then we will plan. As per our plan, we are giving API version to be v1, kind will be pod, metadata will be used in order to name the pod. We are giving counter as the name. Then comes specification of the container where we have to specify stdout and stderr kind of logging. To do that, we are giving a name to the container. We are using an image, that is busybox. Then we are using args where we are passing 3 essential arguments. First, /bin/sh followed by a comma. After comma, we are specifying -c followed by a comma. And third argument is the log that we want to log using stdout and stderr. To do that, within single quotes, we have written I equal to 0 to start the counter, semicolon, while true, followed by semicolon, and then we are writing do echo within double quotes $I to track the value of I, followed by colon, followed by dollar within brackets date in order to capture the date, followed by a semicolon after closing the double quotes. Then we are writing I equal to dollar within double brackets I plus 1 to increment, followed by semicolon, and finally we are using sleep followed by space 1 in order to send it to sleep for 1 second. After our logging is done, we are specifying done and closing single quotes. This particular configuration file will capture containers log using stdout and stderr. We'll save the file by pressing escape:\wq followed by an enter key, and then we'll go and we'll create the pod. To create the pod, we'll write kubectl followed by space apply followed by space -f followed by space name of the file where we have written configuration for capturing containers log. After writing the command, we'll press enter, and once you'll press enter, you'll find that pod is created. And once you will get into pod, you'll find that it is logging after every 1 second. This is how you will be able to write configuration file that captures containers log using stdout and stderr. In this video, we'll install CRI-CTL and demonstrate use of CRI-CTL commands to debug container runtime on Kubernetes cluster. CRI-CTL is a command line interface which is built for CRI-compatible container runtimes. We can use CRI-CTL to inspect and debug container runtimes and applications which are even present on Kubernetes node. Let's go ahead and first install CRI-CTL. To do that, first we will set the version, and that we will do by writing version equal to, within double quotes we'll write v1.19.0 and we'll press enter. Now version is set. To download it using curl, we'll be using curl command followed by space -l followed by space the location from where we want to download. We'll specify --output after specifying the URL and giving a space, followed by space CRI-CTL $$ within curly braces version, and this will be replaced by the version that we have set in the previous step, followed by -Linux, followed by -AMD64.tar.zz. We'll press enter. Now once it is downloaded, you have to configure it. To configure, you'll be just using one single command that starts with sudo in case if you are not a super user. If you are a super user, you can avoid using sudo. You need to write tar followed by space zxbf followed by space CRI-CTL $$ version -Linux AMD64.tar.zz followed by space -c followed by space /usr/local/bin. We'll press enter. Once you'll press enter, it will show you CRI-CTL. Finally, once it is installed, we'll remove it by using rm followed by space -f followed by space CRI-CTL $$ version -Linux AMD64.tar.zz. We'll press enter. So now we have installed CRI-CTL. Let's go ahead and view the configuration file. To view the configuration file, first we'll clear the screen by writing clear. After clearing the screen, we will list all the pods, but now we will be using CRI-CTL command. To do that, we'll write CRI-CTL followed by space pods. We'll press enter and you'll find that it gives list of all the pods.
You can use CRI-CTL to search for a particular pod even by using name. Now let's go ahead and use CRI-CTL command to list all the images. To do that, we'll write CRI-CTL followed by space images and we'll press enter. It will list all the images that are pulled from the repository. Now assume that we want to get the logs in order to debug a container. In order to get containers, we will be writing a command that starts with CRI-CTL followed by space followed by PS. We'll press enter. Once you'll press enter, it will list various different containers which are running. We'll select one of the container ID. For example, we are selecting one of the container ID. After selecting the container ID of our choice, we'll clear the screen and we'll write CRI-CTL followed by space logs followed by space ID of the container. Once you'll specify ID of the container and you'll press enter, you will get logs of the container. This is how you can install CRI-CTL and use CRI-CTL commands to debug container runtime on Kubernetes cluster. In this video, we'll install and use Telepresence to create a virtual network between local machine and the remote Kubernetes cluster to simplify debugging of application running on Kubernetes. Now, our first task is to install Telepresence, which is an open source tool that helps to run a single server locally while connecting that service to a remote Kubernetes cluster. It's a useful tool for developers who are working on multi-service applications. Let's go ahead and see how to install Telepresence. To install Telepresence, you need to first decide what is your operating system. Depending on your operating system, you need to download the binaries and do the installation. We are using Ubuntu, so we'll be downloading Ubuntu package. To do that, we'll be writing a command that starts with curl followed by space -s followed by space and the end point where that install script is, followed by space pipe, followed by space sudo, followed by space bash. We'll press enter. Once you'll press enter, it will detect operating system, it will check for curl, detect curl, and it will start installing all the dependencies. We'll wait for repository setup to be done. Now, once repository setup is done, we have to install. To install, we'll be using a command that starts with sudo in case if you are not super user. If you are super user, you can avoid using sudo, followed by space apt, followed by space install, followed by space --no -install -recommends, followed by space and telepresence. After writing the command, we'll press enter. Once you'll press enter, it will ask, do you want to continue? We'll press capital Y and enter. Finally, you'll find that Telepresence is installed. Now we can use Telepresence to connect to a remote cluster from a local process. And this allows us to use local tools on local systems as well. Now let's go ahead and start by running a service in a cluster. To do that, first we'll clear the screen. After clearing the screen, we'll use a simple command in order to create a deployment first. To create a deployment, we'll be using kubectl followed by space, followed by create, followed by space, followed by deployment, followed by space, name of the service, we are giving it as sample service, followed by space, followed by --image equal to busybox. After writing the command, we'll press enter. Once you'll press enter, you'll find that deployment called sample service is created. Now we need to expose the deployment at a particular port. To do that, we'll write a command that starts with kubectl followed by space expose, followed by space deployment, followed by space sample service, followed by space --port equal to 8000. We'll press enter. Now, once you'll press enter, you'll find a message that indicates that now your sample service is exposed. Now, let's go and get details of the service. To get details of the service, we'll be using kubectl followed by space get, followed by space service, followed by space sample service. We'll press enter after writing the command. Now, once we press enter, we'll come to know what is the cluster IP and what is the port. Using service name and the port, we'll be able to access it. For example, let's go and use Telepresence followed by space, followed by --run, followed by space curl, followed by space, we'll use HTTP,
:// followed by name of the service, which is sample service, followed by colon, and finally we'll specify the port followed by a slash. We'll press enter. Once you'll press enter, you'll find that it displays the content which is present at the specified port for that particular service. This is how you can use Telepresence in order to quickly debug applications which are running on Kubernetes cluster. In this video, we'll demonstrate use of kubectl log command to print logs from a specific container within a pod, logs that occurred after an absolute time, logs that are newer than a duration and include timestamp in the log lines. Now let's go ahead and select one of the pods with a running container. To do that, we'll confirm that pod that we are selecting is running. To do that, we'll write kubectl followed by space, followed by get, followed by space, pod, followed by space, and we'll give name of the pod on which we want to apply logs. To do that, we'll write copy-demo, we'll press enter. You'll find that copy demo is in running state. Once it is in running state, you need to know container which is running. For copy-demo, we have created a container by giving nginx as name of the container. Now let's go ahead and log entries that are present in copy-demo pods nginx container. To do that, at the prompt, we'll write kubectl followed by space, followed by logs, followed by space, followed by --tail equal to 1 in order to get most recent line, followed by space, name of the pod, which is copy-demo, followed by space -c, followed by space, name of the container, which is nginx. After writing the command, we'll press enter. Once you'll press enter, you will get most recently logged information. Now, if we want to stream the log of nginx container in the copy-demo pod, we can use it by writing kubectl followed by space, followed by logs, followed by space -f, followed by space --since equal to 10s, followed by space, we'll give name of the pod, which is copy-demo, followed by space -c, followed by space, name of the container, which is nginx. After writing the command, we'll press enter. Once you'll press enter, it will stream the logs. So whenever someone will interact with that particular container, you'll find that log entry comes here. Now you can wait. Whenever someone will be using this pod, you will get the entry. Relevance of since equal to 10 second in above command is you'll get all the log lines from the start of the container along with date and time. So by using various different flags which are available with kubectl space logs command, you'll be able to use log command to print the logs from a specific container within a pod, logs that occurred after an absolute time, logs that are newer than the duration and includes timestamps in the log lines. It is suggested to go through all the flags of logs. So in this course, we have examined how to debug pods, create audit policy, capture and print logs, and work with CRI, CTL, and Telepresence to debug container runtimes and applications. We did so by exploring the common and critical issues associated with pods and replication controller that requires debugging. The approach of debugging pending pods and down or unreachable nodes of a Kubernetes cluster, along with the process of debugging scheduled and running pods in a Kubernetes cluster. The features and roles of Kubernetes auditing, audit policy, the known stages of lifecycle inside the Kube API server component, and how to create an audit policy file and use it to set up and enable policy for cluster. How to install CRI CTL and utilize CRI CTL commands to debug container runtimes on Kubernetes clusters, along with how to install and use Telepresence to create a virtual network between a local machine and a remote Kubernetes cluster to simplify debugging applications. The features of the prominent tools that can help aggregate different logging layers, the log types found in Kubernetes and how to print the logs from a specific container within a pod, logs that occurred after an absolute time and logs that are newer than a duration. In the next course, we will explore the key elements, measurable and performance metrics of Kubernetes to monitor, the various states of Kubernetes clusters, how to perform liveness probe and retrieve the current metrics, CPU, and memory usage of Kubernetes nodes. In this video, we'll describe goal of monitoring Kubernetes cluster and the differences between logging and monitoring. Once your Kubernetes cluster is up, you will have multiple different applications running on it. You'll have various different Kubernetes resources that will play important role in order to make your applications available. It can be container, pod, storage, network. There are various different components. So you need to ensure that you are able to apply right monitoring in order to know real-time status, and in case of any errors, you are able to respond quickly, for which you need to adopt right monitoring practice. Let's go ahead and talk about primary goals of Kubernetes cluster monitoring. First goal is to control resource consumption. Second goal is to ensure that you are able to distribute application load across your host infrastructure, which contains master and worker nodes. Third essential goal is to adopt automatic load management across different instances of applications. And apart from that, when you are using Kubernetes, you need to also ensure that you are able to identify resource consumption and existing resource limits. Apart from that, there are various other goals that we need to keep in mind. And first is to ensure that you are able to plan transitioning of an application instance from one host to another when shortage of resources are identified in host. Second, you need to facilitate capability to automatically scale additional resources. And third goal of Kubernetes is to simplify performing canary deployments and rollback. Now, what to monitor in Kubernetes cluster? First is cluster resource usage. Now, when you are administrating cluster, you need to have enough usable resources in your cluster so that you are able to avoid running into issues when scheduling pods or deploying containers. If you don't have enough capacity to meet the minimum resource requirement of all the containers, you need to scale up your nodes capacity by adding more nodes to distribute the workload. Second is node resource consumption. You need to have continuous monitoring on node resource consumption as well. Beyond simply keeping track of nodes in your cluster, you need to monitor usage of CPU, memory, and disk. For Kubernetes nodes, it can be worker as well as master so that you are able to ensure that your cluster is healthy. Third element that you need to monitor is to monitor for missing pods. From time to time, you will find your cluster is missing a pod. A pod can be missing because there was no sufficient resource when they were scheduled. Apart from that, your pod may not get started because it is in a restart loop. Critical reason for that may be misconfiguration. Fourth element that you need to monitor is to find out whether pods are running or not. And finally, monitor so that you are able to troubleshoot container restarts. Now, there are three other essential elements that you have to monitor. First, you need to track container resource usage. Apart from that, you need to also have monitors to monitor storage volume. And finally, always monitor the control plane and its components, which includes etcd, API server, scheduler, and controller manager. Now, let's try to differentiate between monitoring and logging. Monitoring is a critical process of instrumenting cluster to collect, aggregate, and analyze all the available metrics. It means monitoring will heavily rely on metrics to alert IT team to handle operating anomalies, whereas logging is all about creating an ongoing record of application events that are getting generated. Logging is a mechanism that is used to review any event within a system that includes
failures as well as transformations. And finally, let's try to understand how do we set up monitoring for Kubernetes cluster. And that we will do using a diagram which is currently displayed on the screen. At the right hand side, you have your cluster, which has pods, daemon sets deployed on nodes. You want to give better user experience, better application availability, robust infrastructure, and insight to business to evaluate existing applications capability. And that can be taken care by applying various different kind of services that facilitate in setting up right monitoring system. It includes metric service, alert service, event service, EUM service, and analytics service. These services will keep on tracking metrics whenever there is a request to access an application which is being orchestrated and managed by Kubernetes. Now, all the requests can be generated from web browsers, mobiles, as well as IoT devices. So, before you plan monitoring, you need to identify the goals of monitoring. You need to identify components that you will monitor and then plan setting up right monitoring system in place. The objective of this video is to list the key elements of Kubernetes that needs to be monitored in Kubernetes cluster and recall the differences between white box and black box monitoring. Now let's try to understand what all are the services and the components that need to be monitored in Kubernetes cluster. First service, which is very critical, is kube-API server. It's a component of Kubernetes control plane, and responsibility of this component is to expose the Kubernetes API as front end, which can be used by administrators and developers to place their request. Second component is etcd, which is considered as a consistent and highly available store that maintains data in form of key value. It is used as Kubernetes backing store for all cluster data. When you do installation of Kubernetes, etcd also gets installed as a service. Third component is kube-scheduler. Objective is to keep watch for any newly created pods with no assigned node and then select a node for them to run on. And it heavily depends on affinity that you have specified. Fourth component is kube-controller-manager. Objective is to watch the state of your entire cluster using API server. It will watch for features and make changes to move cluster to a desired state. So it's a continuous task that will be done by kube-controller-manager in order to take care of cluster and ensure that it's always healthy. Now we'll have a technical understanding of how do we set up monitoring. Kubernetes does not have its own monitoring system. And this is the reason why we need to select an external monitoring system. Let's try to understand how do we set up monitoring using a diagram which is currently displayed on the screen. Our diagram contains components like KubeSphere UI, which leverages tools like Prometheus, Kube State Metrics, Node Exporter, Service Monitor, as well as various different predefined rules which are maintained in Prometheus. KubeSphere UI will be used in order to build KubeSphere monitoring and alerting system, and for that it will be using the API. Then comes role of Prometheus operator and Prometheus API, who will be integrating monitoring capabilities of Prometheus to your Kubernetes. You can have Prometheus HA in place. In order to set up Prometheus HA, you need to have instances of Prometheus stateful set, which can be multiple. In the current diagram, we have two. First is Prometheus stateful set -1. Second is Prometheus stateful set 2. Then comes node management and monitoring, which is taken care by Node Exporter, CAdvisor, and Kubelets. Kubelets will also generate logs which can be used in order to monitor current working mechanism of Kubelet and how actually it is serving to the requests. Apart from that, you have kube-state-metrics and K8s API server, which need to be configured in Prometheus for monitoring. Then comes the alerting system. As the diagram indicates, you have four essential components which makes up your alerting system. First, you need to provide alert config mechanism so that alerts can be configured depending on certain thresholds. You have alert engine who will be responsible to process all the alerts. Apart from that, you will have notification engine in order to configure and manage all the notifications that it has to send and receive. And finally, all the data which is generated as a result of alerting mechanism will be stored in database. So these are the various components that you have to use in order to set up robust monitoring system. Now we need to list types of monitoring approach. There are two types. First is black box monitoring and second is white box monitoring. Black box monitoring refers to monitoring of servers where your focus will be on areas like CPU usage, memory usage, load averages, and others. In other words, black box monitoring is all about testing externally visible behavior which will be visible to the users. Whereas white box monitoring is all about monitoring applications which are running on the server. In our case, on Kubernetes containers. Black box monitoring is based on the metrics which are exposed by internal components of system. Let's try to understand using a diagram which is currently displayed on the screen. We have two different diagrams. Black box monitoring is all about ping, API call, load time, response time, and SSH. White box monitoring is all about identifying internal metrics, getting internal log data, and creating traces for internal systems. White box monitoring is all about monitoring which is based on metrics exposed by internal components of the system. Now let's try to quickly differentiate between black box versus white box. Objective of black box monitoring is to provide better overview of situation. It helps to optimize the system by identifying external factors that may impact the system. It allows to find hidden errors and it leads to efficiency in finding errors and problems. Whereas white box monitoring is all about identifying the right metrics which can be provided by log based monitoring techniques. It is typically based on metrics exposed by internal components of the system, and white box monitoring is encouraged to be used when you want to perform advanced detection of behaviors. So, by identifying the right approach to monitor Kubernetes cluster, you need to decide what components you will monitor as part of black box monitoring and what components you will monitor as a part of white box monitoring. In this video, we'll recognize the measurable metrics of Kubernetes cluster that helps discover resource utilization of entire cluster along with the approaches that can be used to collect metrics from Kubernetes cluster and export them to external endpoints. Now first we'll classify critical measurable metrics. First is node resource utilization. There are many metrics which will help you to identify node resource utilization. It can be network bandwidth, disk utilization, CPU, and memory utilization. Once you have utilization metrics in place, you'll be able to decide whether to increase or decrease the number and size of nodes in the cluster. Second critical measurable metrics is number of nodes, which are available to distribute the load. This helps you to figure out what is current size of the cluster and what happens when you add more. Third is running pods. The number of pods running will show you if the number of nodes available is sufficient and if they will be able to handle the entire workload in case if there is node failure. Apart from this, we need to also understand that what approach we need to adopt to collect metrics from Kubernetes cluster. There are multiple different ways. We are going to talk about those approaches which are native to Kubernetes. First is using Kubernetes daemon set. This is one of the approach that is used to monitor all cluster nodes, and that is done by creating a special kind of Kubernetes pod called as daemon sets. Kubernetes will ensure that every node created as a copy of daemon set pod, which virtually enables one deployment
to watch every machine in the cluster. Second approach is using Hipster. It's a uniform platform adopted by Kubernetes to generally send monitoring metrics to a system. We can say that Hipster is a bridge between cluster and a storage that is designed to collect and project metrics. Now let's try to understand how do we configure monitoring to Kubernetes cluster. In order to understand how do we do it in production environment, we would like to configure an external provider. Assume that external provider is sample cluster, which is a monitoring tool. To configure it, we'll be writing a manifest file where our entries will be API version rbac.authorization.k8s.io/v1. Kind that you have to specify is cluster role, which is a kind of service. Then comes metadata where you'll be specifying name of the monitoring system. For example, if name of the monitoring system is sample cluster, you'll specify that. If it is Prometheus, you'll specify Prometheus. And then comes the rules where you'll be specifying non-resource URLs and you'll specify /matrix within double quotes. And finally, you have to specify the verbs, which is get. Another approach is to design metrics pipeline. Now let's try to understand how to come up with core metrics pipeline for Kubernetes. To do that, we need to install metrics server. Assuming that we have installed metrics server, let's try to understand the architecture of metrics pipeline using a diagram which is currently displayed on the screen. Kubectl will be used in order to communicate with metrics API, as well as it will be used by user in order to invoke various different activities. Your metrics API will also get metrics populated by HPA, and all this will be sent to metrics server. In turn, metrics server will interact with resource metrics manager, which are present on nodes. There are two types, resource metrics and custom metrics. These type of metrics will be created using various different components. For example, resource metrics will be projected using CAdvisor via kubelet, or it will also use node exporter, whereas custom metrics is all about how well you have instrumented pods, and it will use kube-state-matrix. Prometheus will also keep track of these metrics as a part of monitoring. So depending on what kind of metrics you are going to use, your metrics server, metrics API will help to design a pipeline and build a flow that can be used by Prometheus as a monitoring solution. Apart from that, you can also use exporters to use the metrics which are populated. One of the essential tasks as a Kubernetes administrator is to identify the right metrics that need to be measured in order to keep track of Kubernetes cluster and ensure that they are always healthy. In this video, we'll create a configuration file and write configuration that can be used to create and start node problem detector that monitors and detects node problems. Now we need to first understand that node problem detector is a daemon set that monitors the node's health. How does it work? It collects node problems from various other daemons and reports them to the API server as a node condition and events. So as an administrator, we need to be clear about node condition and event in order to declare what is the current health of a node. Now currently, Kubernetes does not take any action on node conditions and events generated by node problem detector. But yes, they are planning to come up with some solution to introduce dynamically dealing with node problems which are identified by node problem detector. Now assume that we have Kubernetes cluster and we have installed all the utilities that are needed. Our objective is to install node problem detector so that it can detect problems which are there in node. If you are working with GCE cluster, it's simple because it is already installed. You can just go and enable and disable. But for other environments, you need to work out in order to make node problem detector available. Kubernetes provides you two different approach. First, you can use kubectl after writing the configuration file.
Second, you can just create a file and you can drop that file in add-ons folder of Kubernetes. First approach is preferred. So let's go ahead and see what configuration need to be done in order to make services of node problem detector available in your cluster. To do that, we need to write a configuration file, and to write a configuration file, we'll write vi followed by space followed by name of the file. After writing name of the file, we'll press enter. Once you'll press enter, you will start the configuration. You need to ensure that you have right set of annotations and labels available in order to complete the configuration. We'll start with API version, which should be app/v1, kind is daemon set. Then comes metadata. In order to give it a name, we are naming it as node-problem-detector-v0.1. Namespace must be kube-system, which is provided by Kubernetes as you install the cluster. Then comes essential labels. First label is k8s-app. It should have value called node-problem-detector. You can have other labels too instead of specifying this. Version we are specifying as another label, and we are specifying version to be v0.1. You can change as you go ahead. Kubernetes.io/cluster-service is another label which will be internally located in order to match it to other internal components. We are setting it to true. Then comes the spec, which contains selector with match labels that we have specified in labels of metadata of the current object. Then comes the templates. We are specifying metadata, and again we are specifying the same labels that we have specified in selector specification. And then comes the most important spec, which should be inside template, and that spec contains host network. We are setting it to true. Containers, we are giving a name. That name is node-problem-detector, and we are using an image which is provided by GCR. Endpoint of the image is k8s.gcr.io/node-problem-detector:v0.1. Then comes security context. We are setting it to privileged by setting true as value to privileged attribute. Post that, we are setting the resources, applying limits on CPU and memory, which is 200 M for CPU and 100 MB for memory. Now, what about requests? Apart from limits, we are setting requests where CPU is 20 M and memory is 20 MB. And finally, we are specifying the volume mounts where we are giving a name as log, mount path as /log. We are making it read only by setting read only attribute of volume mounts to true. Then comes the volume. We are giving the name which we have specified under volume mounts, it's log, and we are specifying host path where path contains value which is /var/log. You need to ensure that the system log directory is right for the operating system distribution that you are using. After creating the file, we will save the file. To save the file, we'll press escape followed by :wq. Now we are out of editor. Now let's go ahead and start node problem detector using kubectl command. To do that, we'll write kubectl followed by space apply followed by space -f followed by space name of the file, which is c17_v5.yml in our case. After specifying the file name, we'll press enter. Once we'll press enter, we'll find that it shows a message indicating that daemon set, whose name is app-problem-detector-v0.1 is created. Now let's clear the screen. After clearing the screen, we'll write kubectl followed by space get followed by space daemons followed by space -- all namespaces. After writing the command, we'll press enter and it will give list of all the daemon sets which are running. We can see with namespace named kube-system, we have node-problem-detector-v0.1 daemon set available. You have 2 available and 2 node selector as well. This is how you will be able to create a configuration file and Write configuration that can be used to create and start node problem detector, which monitors and detects node problems. In this video, we'll show how you can update kernel monitor with new condition definitions by editing conditions field in config/kernel-monitor.json configuration file provided by node problem detector. To do that, we need to open a file. Let's go and open the file and see where we need to update in order to get the desired definition as well as the rule. We'll connect to the master where we have that file and open the file using the editor of our choice. To do that, our current case will write notepad because we are using Windows followed by name of the file, which is node-problem-detector-config.yaml. Before you create components, you need to ensure that you have applied your condition and you have defined the rule of your choice for kernel monitor. Let's go ahead and open it. Once you'll open the file, first entry that you will get is API version, which is v1, followed by data, and then comes kernel-monitor.json. This is the file where you have to update. We'll directly go to conditions element, which contains all the conditions in form of an array, which is defined in YAML using opening and closing square brackets. Now we want to add a new condition. To add a new condition, we'll go to the last condition, put a comma, press enter, and then write our new condition. Condition that we have added now is type, node condition type. Reason, we are specifying a reason, that is camel case default node condition reason. Apart from that, a message. So depending on whatever condition you want to add, you can go ahead and you can add it within opening and closing square bracket of conditions. Then comes the rule. Now, in order to detect new problems, you need to extend the rules, and that again you will do in kernel-monitor.json. In the same file, just below conditions, you will have rules. There will be multiple rules which are already defined. Now, you want to define your own rule. To define your own rule, we'll just press enter within square brackets and we'll make our own entry to specify the rule. We'll place the cursor at the right place where we want to make entry. After placing the cursor, we will write our rule depending on our choice. For example, assume that I want to add a rule. For that, we need to have an opening and closing curly braces within square bracket, and within opening and closing curly braces, we will have four essential elements. First is type. We are specifying it to be permanent. After specifying the type, we are specifying condition, which is node condition of permanent issue. Then we are giving reason, which is camel case short reason, and finally a message which tells the objective of the rule. And the objective is regexp matching the issue in the kernel log. After we make entry in the file, we need to save it. To save, we'll use the editors command. We'll go to file menu, click on save. So now you have updated your node-problem-detector-config.yml file, which contains kernel-monitor.json and entries where we can update condition and rule and extend capability of node problem detector. After saving the file, we'll use kubectl apply in order to apply the new rules and conditions that we have specified in current YML file. This is how you can update kernel monitor with new condition definitions by editing condition field in config's kernel-monitor.json configuration file. In this video, we'll list the various states of an individual Kubernetes cluster, its master node and worker node. We know that Kubernetes is a container deployment and management platform. Let's have a quick recap of Kubernetes cluster components. There are two essential components which are part of Kubernetes cluster. First is master node and second a set of worker nodes. It depends on architecture that you are adopting. You can have multi-master configurations as well. Master node will contain components like scheduler, storage with key value store, which is etcd, as well as controller manager with internal components which includes replication dash controller, endpoint dash controller, node dash controller, and service controller. API server will be the front end using which master will manage worker nodes and place the workload. Worker node contains kube proxy. Every worker node will have kubelet, and worker node will have pods, which in turn will have containers with application deployed on it. You will have kube dash proxy that plays role of proxying the request to appropriate container which are part of pods. Now, after having a quick recap, let's try to understand node status descriptors that helps us to understand status of worker and master nodes. First is addresses, which is all about what is the IP address, where nodes are running, what scheme need to be followed in order to allocate IPs to pods. Then comes conditions. Condition states what is the current condition of the node, whether it is healthy or it is in some other state. Then comes capacity and allocatable, which means what is the current capacity and what is the allocatable resource which are available in a particular node. And finally, info, which is general information about node status. Address field will contain three essential elements. First, host name. These are the names that are reported by node's kernel. If you want to override, you can do it by using parameter of kubelet. Then comes external IP. It is the IP address of the node that is externally routable, which means it is available from outside the cluster. Third is internal IP. These IP addresses of the nodes are routable only within the cluster, not outside the cluster. Now let's try to understand conditions. Conditions can be identified using 5 important parameters. First is ready. Second is disk pressure. Third is memory pressure. Fourth is PID pressure. And fifth is network unavailable. Let's have an example of type ready and how to specify it. To specify it, we are showing a JSON segment which has conditions within double quotes followed by colon and then object description which contains type to be ready, status is true, reason is kubelet ready, message contains kubelet is posting ready status, and then you have last heartbeat time and last transition time. These are the critical information that will help you to understand condition of a node. In this video, we'll recall the best practices that need to be considered for Kubernetes monitoring. There are certain best practices which we need to keep in mind as an administrator that helps us to identify the right status of cluster and respond to any issues quickly. Let's try to go through certain monitoring best practices. First, keep tracking the API gateway. Avoid measuring individual containers because number of containers will be huge and they are dynamically created and removed. Third best practice is to continuously watch the status and reason dimensions, which will be part of various different log outputs. Fourth best practice is to configure alert on high disk usages. And finally, track application level metrics for each cube dash system components. Cube dash system is the namespace which contains various different components that facilitate in keeping your cluster up and running. Now let's try to understand how do we plan robust monitoring for Kubernetes. First step is always to use Kubernetes daemon set. Now when you are running Kubernetes, you might want to run a single pod on all your nodes. Such as when running a monitoring process, you can use systems like AppDynamics, Fluentd, or any other open source data collector. Second, define consistent and logical labels so that you can quickly query resources on basis of those logical labels. Third, create a checklist of metrics that you intend to monitor. And finally, use service discovery because Kubernetes schedules applications dynamically which are based on scheduling policy. You may not know where your apps are running at the moment. And that's the reason why it is suggested to use service discovery. Now let's go ahead and see how do we configure monitoring in Kubernetes. We do that by creating a manifest file and entering certain configuration details. It should have API version, kind, which is cluster role. It means type of service that you are going to create is cluster role. Metadata should have label, where in the current scenario we are using two labels. One is app monitor, second is component server. Followed by name in order to give a name to the service, and then comes the rules where you are specifying non-resource URL that indicates that it's not a resource URL. Value of non-resource URLs will be /matrix. This defines the endpoint, and then comes type of request, which is defined by using verbs. Current entry in verbs is get. In short, monitoring will use get request to /matrix endpoints as per the current configuration. Now let's try to take up a scenario of configuring Kubernetes monitoring. And we'll do that using a diagram which is currently displayed on the screen. We are using Elasticsearch as the database to store the logs and Kibana in order to do analytics on the log. We are assuming that you have nodes like node 1, node 2, node 3 in the current scenario where logs are getting generated for write metrics. So you will have Apache logs and metrics, or you will have system logs and metrics that will get generated and it will get stored in Elasticsearch. Second node can read logs and metrics, and those logs and metrics can be basically response time and DNS metrics. And then comes Kubernetes logs, which are called as K8s logs and metrics. Apart from that, you will have runtime logs. In the current scenario, it is Docker logs and metrics. All this will be stored in Elasticsearch using index, and that index will be read by Kibana to create visualizations so that administrator can view real-time values of identified and configured metrics. In this video, we'll demonstrate how an administrator can create a configuration file to create a pod that runs a container and specify configuration that ensures that Kubelet performs a liveness probe every 10 seconds and waits for 10 seconds before performing the first probe. As an administrator, we need to create a configuration file in order to ensure that we are able to manage liveness probes. To do that, we'll write a configuration file, and to write a configuration file, we'll use VI editor. We'll write VI followed by space followed by name of the file. After giving name of the file, we'll press enter. Once we'll press enter, we have to start writing the configuration following YML standards. First line is API version, which is specified to V1. Then comes kind, which is pod. Then comes metadata, labels. We are giving a label called test with the key and liveness as the value. We are also specifying name to the pod, which is pod v179. Followed by spec, where we are defining specification of containers. Name of the container, we are specifying a name to the container. Followed by image, we are taking busybox from k8s.gcr.io. Then we are using ARGS in order to ensure that when a container starts, it executes certain commands. To do that, first we are moving to /bin/sh followed by -c followed by touch. After specifying touch, we'll give a space, we'll specify a path that is /tmp/healthy terminated by semicolon. Then we'll give sleep followed by space 1200, terminate it using semicolon, and then we'll do the activity that we want to do. What we are doing is we are removing the files which are present in /tmp/healthy folder, and that we are doing by using rm followed by space -rf followed by space followed by path of the directory. We are closing it and we are giving sleep of 600. Then comes the most important configuration element that helps us to control liveness probe. In the current configuration file, we can see exec followed by command, where we are using cat followed by /tmp/healthy. This will get executed in the target container. Now, if the command succeeds, it returns 0. and the kubelet will understand that the container is alive and healthy. But if the command returns a non-zero value, kubelet will kill the container and it will restart it. Now we have to control how kubelet should perform the probe. Our objective is to ensure that we are able to tell kubelet to perform a liveness probe every 10 seconds, and that we are doing by configuring two essential attributes or fields. First is initial delay seconds, which tells the kubelet that it should wait for 10 seconds before doing the first probe. Now, to perform a probe, the kubelet executes the command that we have discussed. Second essential field is period seconds, which specifies that the kubelet must perform a liveness probe every 10 seconds. In short, initial delay seconds will control the first probe, and period seconds will control every x seconds. We have specified 10 to both in order to meet the need of administrator. Next, we have to save the file by pressing escape to come out of insert mode, followed by :WQ. After writing :WQ, we'll press enter. Now we are out of the file and the editor. Let's go and create the pod. To create the pod, we'll write kubectl followed by space apply followed by space -f followed by space name of the file, which is c17 underscore v9 dot yml in our case. After writing the name of the file, we'll press enter. Once you'll press enter, you'll find that the pod is created. Once pod is created, you would like to see the details of the pod events. To see the details, we'll write kubectl followed by space describe followed by space pod followed by space name of the pod. We are using pod v179. After writing name of the pod, we'll press enter. Once you'll press enter, you'll be able to see normal events because it has not yet failed. It has not yet failed because it is within the seconds that we have specified in the command that need to get executed. We'll wait for some time before we execute it again. You can keep executing and you can keep checking the liveness probe. This is how you can create a configuration file that helps you to create a pod as an administrator that runs a container and specify configuration to ensure that kubelet performs a liveness probe every 10 seconds and waits for another 10 seconds before performing the first probe. In this video, as an administrator, we will be creating a configuration file to create a pod and specify configuration that ensures that the kubelet sends an HTTP GET request to the server that is running in the container and it is listening on the port 8080. First task is to create a pod and configure container with the server. After configuring the server which listens at 8080 port, we will be configuring the probe that need to be sent by kubelet. To do that, we need to create a configuration file. To create a configuration file, we'll be using VI editor. And to use VI editor, we'll write VI followed by space name of the file. And we'll press enter. After writing name of the file, we need to start configuration. It's a simple configuration. We'll specify API version, kind as pod, metadata, followed by label where we are using test as key and HTTP GET as value, followed by name to the pod, which is pod v1710. Then comes the main configuration, which is about spec for the container. And in container, we are specifying 4 essential fields, where first field is the name of the container. Second is the image. We are using an already supplied image by k8s.gcr.io and name of the image is Liveness, followed by args, followed by /server. And then we have to plan liveness probe, which will communicate with the kubelet. Our objective is to ensure that kubelet sends an HTTP GET request to the server and is running in the container and is listening on port 8080. And that's what we have done in the current configuration of liveness probe. We are specifying HTTP GET, followed by path and port, followed by HTTP header in order to send some custom headers, followed by initial delay seconds and period seconds. We are passing initial delay second to be 3 and period seconds to be 3 in order to ensure that kubelet does a liveness probe every 3 seconds. Initial delay seconds tells the kubelet that it should wait 3 seconds before doing the first probe. Now you have various different status that will be returned by the server when the request will be made. It can be 200 plus, it can be 400 plus, or it can also be 500 plus. 200 plus indicates success, 400 plus indicates failed, and 500 plus indicates that there is some issue in the server. After configuring this, administrator will be able to send probe to containers server and check the status of every HTTP GET request that is made to the server. We'll save the file by pressing escape followed by :WQ and we'll press enter. Now let's go and create the pod. To do that, we'll write kubectl followed by space apply followed by space -f followed by space name of the file, which is c17_v10.yml. We'll press enter. Once we'll press enter, you'll find that pod is created. Now, once this pod is created, you can go ahead and check the log whenever there is a request made. In this video, as an administrator, we will create a configuration file that creates a pod and specify configuration that defines readiness and TCP liveness probes. After going through approach of defining a liveness HTTP request in the video title perform a liveness probe using HTTP GET, we will go and now configure the third type of liveness probe, which uses internally a TCP socket. Now, when you use TCP liveness probe, your kubelet will attempt to open a socket to your container on a specified port. If it can establish connection, container is considered healthy. If it cannot, it is considered a failure. Now let's go ahead and write the configuration file to define TCP liveness probe. To do that, we need to write configuration file. We'll write configuration file by using vi followed by space name of the file. We'll press enter. After specifying name of the file, we'll configure a pod using YML standards. We'll specify API version to be v1, kind to be pod, then in metadata we'll give name to the pod, we'll specify a label. We are using label key as app and value as TCP probe. Then we have to specify specification for containers where we'll use name followed by image. We are using k8s.gcr.io/goproxy:0.1, an image which is ready to be tested for TCP probe. Then comes the ports. We are using container port to be 8080. You can change the port depending on your need. You are also specifying readiness probe. Readiness probe contains TCP socket where we are specifying port to be 8080, followed by initial delay seconds, which is 10, period seconds is 15. After configuring readiness probe, we will configure liveness probe as well, where TCP socket will contain port to be 8080 or port of your choice. In case if it is 80, you can specify 80. Followed by initial delay seconds to be 20, period seconds to be 25. This number also can be configured by you as per your need. Now, in the current configuration, apart from readiness probe, we have also configured liveness probe. Kubelet will run the first liveness probe as it is specified in initial delay seconds and period seconds, and it will also attempt to connect to the container on the specified port. Now, if the liveness probe fails, your container will again be restarted. Now, let's go ahead and create the pod. To create the pod, we'll press escape followed by :WQ. Once we are out of editor, we'll be using kubectl followed by space apply followed by space -f followed by space and name of the file. After specifying name of the file, we'll press enter. Once you'll press enter, you'll find that your pod is created. Now you can write the command called kubectl followed by space describe followed by space pod followed by space name of the pod, which is pod v1711. After writing the name of the pod, we'll press enter. Once you'll press enter, you'll find pods event that helps you to understand what is the outcome of liveness probes. This is how you can create a configuration file to create a pod and specify configuration that defines readiness and TCP liveness probes. In this video, we'll list the key Kubernetes performance metrics that needs to be monitored to get data about the count, health, and availability of various Kubernetes objects. As an administrator, we need to always classify those metrics which will have impact over performance. And that's the reason why we call them as performance metrics. First component and key metrics of those components which will have impact over performance are API server. So let's go through certain API server key metrics. First is response latency. Second is rate of API server request processing. Second component is etcd, which maintains store for your Kubernetes server. Let's try to understand those key metrics of etcd which will have impact over performance. First matrix is has_leader. This matrix will help us to identify whether or not a leader exists. Second is etcd_mvcc_db_size, which is in MB bytes. It indicates total size of underlying database in bytes. And third, what amount of messages are streamed, that is, amount of stream messages sent or received. And finally, what is the current latency distribution. Apart from that, key metrics that have impact over performance from perspective of etcd are disk write performance, that describes what is the disk write performance of your current storage, and raft proposal, that ensures that the proposals are applied correctly to the cluster. Then comes third essential component which plays important role in pod placement, and it is kube-schedule. Let's go through certain key metrics of kube-schedule. First is scheduler schedule attempts. It defines the number of attempts that are made to schedule pods. Unschedulable means a pod could not be scheduled, while error means there is an internal scheduler problem. Second metric is scheduler schedule attempt rate. It's the rate of the number of attempts that are made to schedule pods. And third is scheduler scheduling latency. It indicates end-to-end scheduling latency, which is the sum of scheduling algorithm latency as well as binding latency. And finally, there are certain resource metrics which also need to be considered in order to track performance. First is memory, and metrics are memory requests, memory limits, memory utilization. CPU, CPU requests, CPU limits, allocatable CPU, and disk utilization, as well as disk pressure signal. So by using the right metrics for monitoring, you will be able to track values that will help you to identify the current performance and what need to be done in order to provide consistent performance of your Kubernetes cluster. In this video, we'll demonstrate how to query the metrics API to retrieve current metrics from any node or pod and get the CPU and memory usage of a particular Kubernetes node and pod. Once you are sitting on a particular system and you want to use metrics API to query for resources, you need to first confirm whether it is installed or not. In order to do that, we'll write kubectl followed by space followed by get space followed by deployments followed by space followed by -n followed by space followed by the namespace. Namespace that we are using is kube-system because this is the place where you will have your metrics server installed. We'll press enter. Once you'll press enter, you'll find that you have metrics server installed. Now let's confirm what all pods are there and identify the pods which are used by metrics server. To do that, we'll write kubectl followed by space followed by get followed by space pods followed by space dash n followed by space cube dash system and will press enter. Once you'll press enter, you'll find metrics server pod is installed. Now we have to plan how to query using metrics server API. We can query metrics API to retrieve current metrics from any node or pod by using kubectl get commands. But yes, there will be a change, and that change will be we will delegate that responsibility to metrics server. In order to do that, let's clear the screen. After clearing the screen, we'll write kubectl followed by space get. Now, instead of specifying pods or nodes, we'll give a space and we'll write dash dash raw. Followed by space, we'll delegate it to metric server, and to do that, we'll write slash APIs slash metrics dot k8s dot io followed by slash v1 beta 1. It may change in future versions, followed by slash nodes, followed by slash name of the node. Name of the node is docker dash desktop. After writing name of the node, we'll press enter. Once you'll press enter, it will show you the raw usage. You need to go to usage attribute of the current JSON and analyze what is the CPU usage and what is memory usage. Now our objective is to go ahead and see the resource usage by a particular pod. To do that, first we will write kubectl followed by space get followed by space pods and we'll press enter. We'll come to know what all pods are there. We'll identify the pod whose usage we want to know. And we'll write command once again that starts with kubectl followed by space get followed by space dash dash raw followed by space slash APIs slash metrics.k8s.io slash v1 beta 1. Now we need to specify the namespaces in order to ensure that we are able to target pods which are present in different namespaces. After specifying slash namespaces slash, you need to give name of the namespace. Our current namespace is default, so we are specifying default followed by slash pods followed by slash name of the pod. Name of the pod we can see as deploy 1 dash alphanumeric. We'll specify name of the pod and we'll press enter. Once you'll press enter, you'll come to know what is the current CPU usage and memory in kibibytes which is being used by your current pod. You can use similar mechanism in order to get details of various different pods. Please remember that metrics API returns a JSON object. You can pipe the response and send it to metrics aggregator where visualizations can be created and also information can be made available in better formats. This is how you can query the metrics API to retrieve current metrics from any node or pod and the CPU and memory usage of a particular Kubernetes node as well as pods. You'll be using similar commands irrespective of your cluster architecture. So in this course, we have examined the key elements, measurable and performance metrics of Kubernetes to monitor, the various states of Kubernetes clusters, how to perform liveness probe and retrieve the current metrics, CPU and memory usage of Kubernetes nodes. We did this by exploring the key elements of Kubernetes that we need to monitor in a Kubernetes cluster and the measurable metrics of Kubernetes cluster that helps discover resource utilization of entire cluster. The goal of monitoring Kubernetes cluster, the differences between logging and monitoring and the best practices for Kubernetes monitoring. How to create a pod running a container and specify the configuration to ensure kubelet performs a liveness probe every 10 seconds. Sends HTTP GET request to the server running in the container and defines readiness of TCP liveness probes. How to create and start the node problem detector to monitor and detect problems associated with nodes and how to update the kernel monitor with the condition definition. The key Kubernetes performance metrics that we need to monitor to get the count, health, and availability of various Kubernetes objects. In the next course, we will learn to troubleshoot Kubernetes service issues, perform end-to-end diagnosis, investigate, track, and fix issues of pod and services.
In this video, we'll recognize the Kubernetes components that need to be investigated to plan Kubernetes troubleshooting. Kubernetes have diversified components, but we need to adopt right approach to troubleshoot. There are two essential components which should be focus of troubleshooting. First is application troubleshooting, which is useful for users who are deploying their applications into Kubernetes, and sometimes they may be in a situation where they may find out that it's not working. Second scenario is cluster troubleshooting, which is useful for cluster administrators in order to ensure that they are always keeping cluster healthy for applications to be deployed. And this is the reason why we divide it into two different sections when it comes to troubleshooting. First, application troubleshooting. Second, cluster troubleshooting. Now we need to focus on identifying components that we need to investigate for troubleshooting. Now, whenever there is an issue, we need to have a plan to start investigation. So we'll go and we'll investigate various components of Kubernetes. Let's start with two most essential Kubernetes components which keeps cluster healthy. First is master. It's the system from which you manage your entire Kubernetes environment. And second component is nodes, which are worker nodes, where your containers with applications are deployed. Apart from that, you need to also focus on investigating pods and services, because pod defines one or more containers to run, as well as it provides option to use container runtime command for each container and labels to define the location where actually service is present. Then comes services. Services allows a container which is within your Kubernetes environment to find an application provided by another container by using name and without using actual IP address. So sometimes you'll be in a situation where service is not reachable, where pods are not behaving the way you want. They are not providing you containers which are in right stage. You need to focus on investigating by going through various different log files and identifying what can be done. Next, there are two other essential components which you need to investigate. First is replication controller, that helps you to designate a certain number of pods that should be available and running. Now, new pods are started until the required number is reached, or if a pod dies. Whenever a pod dies, a new pod is run to replace it. That's what is basic objective of a replication controller. And finally, networking, where you have various different CNIs that helps you to implement network model. One of them is flannelD. It's a service that lets you to configure IP address ranges and related settings to be used by Kubernetes. So by identifying the right section of troubleshooting and delegating it to the right administrator, who will be doing investigation from their perspective of various different components of Kubernetes cluster, will help to have a stable cluster always available and ready to deploy new applications. In this video, we'll list the commands that can be used to troubleshoot components of Kubernetes cluster. After going through various different components that need to be investigated in previous video of this course, now we need to focus on commands that are used for troubleshooting. First command is kubectl, which is most popular command used by Kubernetes administrator as well as developers in order to send their request to Kubernetes kernel. Second command is systemctl. It's a command that is specific to operating system, specifically if your operating system is systemd. It helps you to get details of current resources which are being used by Kubernetes and their state. Third is journal.ctl, which helps you to get details of log. Then comes etcd.ctl. It's a command that helps you to send your request to create backup, restore to your etcd cluster. Now let's go through each one of them and understand what role they can play. We need to know that kubectl runs from the master. It helps you to create, delete, get, and perform various other actions on pods, services, and replication controllers. Apart from that, you can also manage deployments and stateful sets. Kubectl can also be used to test YAML and JSON files, because these are two popular files where you'll be writing your manifest file that describes objects that you want to be created in Kubernetes to manage your applications. Then comes systemctl command. Systemctl is configured with Kubernetes to facilitate communication between master and worker nodes. And those services must also be active and enabled. Then comes the last, that is etcd.ctl. It's a daemon that manages storage of information for Kubernetes cluster, because etcd cluster is treated as de facto place of storing information. It can run on master or on other systems. etcd.ctl can be deployed and installed on systems which are RHEL or RHEL atomic host systems. And apart from that, we can use curl command instead to query etcd services. You need to ensure that all the services which are there in your cluster are in sync and healthy. How to know that? In order to know that, you can use these popular commands which we have listed. By using these commands, you'll be able to identify the root cause and plan your troubleshooting mechanism to bring back your Kubernetes cluster in healthy state if it is unhealthy. In this video, we'll recall the techniques that can be adopted to troubleshoot issues with etcd database. Primary objective of etcd database is to work as a backend for Kubernetes. Sometimes you may have issues. Now let's try to understand what approach we need to adopt in order to troubleshoot etcd issues. First step is to check etcd container status, followed by a deep examination of container logging. You need to also conduct etcd cluster connectivity checks in order to ensure that your Kubernetes is able to connect to etcd cluster, specifically if you have installed Kubernetes which is communicating with external etcd clusters. And finally, configure etcd alarms in order to ensure that you are notified whenever a particular threshold in terms of resources are reached. Now we'll discuss about few other approach that we can adopt, out of which first is watch and stream events, for which you can use various different commands which are provided by etcd.ctl toolkit. Second is we can replace or we can remove failed or unhealthy node before adding a new etcd node to the existing etcd cluster. And next is to ensure that you are exploring etcd space errors. How do we do that? We do that by identifying compact key space, applying defrag on all etcd members, checking endpoint status for availability, and finally we can disarm all the alarms. Now we need to understand how do we monitor etcd cluster, and that we will do using a diagram which is currently displayed on the screen. On the screen we can see Kubernetes master and worker nodes, where Kube API server communicates with etcd for storage, and it also manages essential components of Kubernetes master like controller manager, scheduler, kube-dns as well as kubelet. Nodes will have kubelets in order to enable communication so that they can place their request to Kube API server. Apart from that, you will have pods, and pods will have container runtime And container runtime will use kubeproxy in order to communicate. Now, where does etcd monitoring comes into picture? Primary objective of etcd is to ensure that it provides a distributed key value dynamic database to maintain configuration registry. So you need to keep close watch on registry because this particular unit facilitates Kubernetes cluster for service discovery, peer discovery, as well as centralized configuration management. You can use various different monitoring tools in order to monitor what's going on internally in etcd and how actually it is negotiating with Kube API server for storage. And finally, when we talk about monitoring, what to monitor is important. And there comes role of etcd metrics that need to be monitored. We have identified 4 very critical metrics. First metrics is has underscore leader, which indicates whether or not a leader exists. 1 indicate existence, 0 is non-existence, and type is gauge. Second metrics is leader underscore changes underscore seen underscore total, which is a fixed number of leader changes which are observed, and that's the reason why type is counter. Third is proposals underscore applied underscore total, which indicates total number of pending proposals. This type of matrix is gauge. And finally, you have proposals underscore failed underscore total. These are total number of failed proposals which are concrete in terms of number, and this is the reason why this type of matrix is counter. So when you want to troubleshoot etcd, you need to understand what impact its health will have on your existing Kubernetes cluster, what are the essential metrics that you need to monitor, and then finalize your monitoring and troubleshooting plan. In this video, we'll list the critical problems faced by administrators when managing pods and describe the recommended approaches that can be adopted to fix the identified issues. Managing pod is essential because pod contains containers and your applications are deployed in form of containers which has dependency as well as serving application. There are certain critical pod issues we need to be aware about. First, pod stays pending. Second, pod stays waiting. Third, pod is crashing or its health that we see is unhealthy. And finally, pod is running but does not do what it was told to do. It means it is showing weird behavior. Most of the issues are created because of misconfiguration, but yes, let's go through critical reasons that helps us to understand issues of pod and adopt a troubleshooting mechanism. Now, when we say pod stays waiting, it means that pod cannot be scheduled onto a node. Other words, scheduler is not able to schedule a node where pod need to be created. It is typically because of insufficient resources of one type or another, which prevents scheduler from scheduling that pod to existing nodes. Now, how do we manage it? We can manage it by deleting the pod, adjusting resource request, or adding new nodes. And we can come out of this issue also by trying to use a service object that exposes the pod. Now, second critical issue is pod stays waiting, which means that pod is stuck in waiting state and it will be scheduled to a worker node. Waiting is also termed as pending. Now, most common cause of waiting pods is a failure to pull the image. Now, why does it happen? It happens because you are not having the right credentials of repository from where you are pulling the image. How to resolve these issues? Issues related to pod stays pending or waiting can be, you have to make sure that the image name is correct. That's the first check that you have to do. Then check if the image has been pushed to the repository which you are trying to pull. Third, run a manual pull on local machine to check if the image can be pulled. In the current case, we are talking about Docker pull, but it depends on which repository you are using. Now, the third and the final issue that we are going to discuss here is pod is running but not doing what it was told to do. Now, why does it happen? Now, when you find pod not behaving as expected, your reason may be due to an error in pod description. It may also be due to incorrect key name. Now, how do we take care of this issue? To take care of this issue, we can delete the pod and create again. Apart from that, we can also check whether the pod on the API server matches the created pod or not. So depending on what is the issue, you have to use appropriate commands to know the issue, identify the reason, and then troubleshoot it to bring it back in the right state. In this video, we'll use commands to diagnose that helps to investigate and verify if Kubernetes services are active and are enabled. Now first, as an administrator, let's go ahead and see what happens when we try to access a service which does not exist. To do that, we'll go to the prompt, we'll write wget followed by space dash o dash, where O is capital, followed by space, and we'll give just a name. For example, let me give a name as test service. After writing this, we'll press enter. Once you'll press enter, you'll find a message that indicates that the service that you are trying to access does not exist. In short, it is not resolving test service to the IP which is specified in the log. It may be because of temporary failure in the name resolution. And finally, you get a message that indicates that you are unable to resolve host address, that is test service. Now, how do we find out services? In order to check a service that actually exists, we'll be writing a command that starts with kubectl, followed by space get, followed by space svc. After writing the command, we'll press enter. Once you'll press enter, you'll find that you have two services which are running. One is Kubernetes of type cluster IP, and second is Kubernetes-sample of type node port. Now let's go and use get command in order to get details of a specific service. To do that, we'll write kubectl, followed by space get, followed by space svc, followed by space Kubernetes-sample, and we'll press enter. Once you'll press enter, you'll be able to get detail of the service. Now let's go ahead and write wget, followed by space dash capital O dash space, and write name of the service that we have written earlier. We'll write Kubernetes-sample and we'll press enter. Once you'll press enter, you'll find that it is temporarily failed. It is only because it is unable to resolve the host address. Now let's go ahead and specify host address. And host address that we will specify is 10.104.44.80. and press enter. Once you'll press enter, you'll find that it is now trying to connect to the service. We'll press Ctrl C in order to exit and clear the screen. This is how you'll be able to use commands to diagnose and investigate to verify if Kubernetes services are active and enabled or not. In this video, we'll list the common failure scenarios while installing or running Kubedium and illustrate the steps that can help understand and troubleshoot the problematic scenarios. There are various different reasons why your installation may fail. Before we go and discuss about critical errors that we get while installation, we need to ensure that we are meeting all the prerequisites for installing Kubernetes cluster. It also depends what kind of Kubernetes cluster architecture you have adopted and what is the minimum prerequisite for that. Similarly, you need to also classify prerequisites specifically for Kubedium so that you can install Kubedium and use Kubedium to manage your clusters. Let's try to list 3 critical scenarios which indicates installation failure. First, error that you are getting is not possible to join a v1.18 node to a v1.17 cluster due to missing RBAC. It means there is issue in role-based authorization control, which can be managed only by distributing the keys properly and ensuring that you are joining compatible node. Second reason is Eptables or some similar executable not found during installation. This particular issue comes when you have not downloaded the right build of Kubernetes, which is made for the distribution where you are doing the installation. And third is kubeadm blocks waiting for control plane during installation, which indicates that critical kubeadm blocks are yet not ready, and this is the reason why installation is not moving further. Now, what about kubeadm failure, assuming that you have installed? But now you are coming into a scenario where kubeadm itself is failing. Let's go ahead and list three critical scenarios. First, kubeadm blocks when removing managed containers. Second, pods in run container error, crash loopback off, or error state, which indicates that now you have to go and you have to debug pods which are required for using kubeadm further. And third is your core DNS or kube-DNS is stuck in pending state. This is expected as part of the design because kubeadm is network provider agnostic. So the admin should install the pod network solution of their choice. You have to install a pod network before core DNS may be deployed fully. And this is the reason why you will find the state as pending before the network is set up. So it indicates that you need to go ahead and install some compatible network model. Now, one of the critical scenarios post-installation that you may face is host and pod failure scenarios. First scenario that we would like to understand is host post services are not working. We know that host port and host IP functionality is available, which heavily depends on pod network provider. So what you need to do is you need to go through documentation of your CNI providers and verify that you are using it in appropriate way. It's not responsibility of Kubernetes, it is responsibility of CNI and CNI provider that you are using. Then comes pods are not accessible when you are using service IP. It may be because many network add-ons do not yet enable hairpin mode, which allows pod to access themselves using their service IP. Again, this is an issue that is related to CNI. So you need to go through documentation of your add-on provider to get the latest status of their support for hairpin mode. Then comes third one, which is TLS certificate error. It is because you are using a certificate which is signed by unknown authority. And that's the reason why when it goes for verification, it fails. Finally, let's go and take up etcd and kubelet failure scenarios. And first scenario that we will take here is non-public IP used for containers. In some situations, you'll find that your log returns error, which indicates that error is coming from server, and when it is trying to get a resource, it is not able to get because there is no route to the host. This particular error may be due to Kubernetes using an IP that cannot communicate with other IPs because of policy that is defined by the machine. Second is etcd pods restart continually, which means that you have encountered an error which is not able to initialize and connection is reset by peer. This issue appears in certain builds. In order to prevent it, you need to ensure that you have taken up the right version of operating system and compliant container runtime that will help you to prevent kubelet from executing into the etcd container. And finally, it's kubeadm reset unmounts /var/lib/kubelet. Now, if you have this particular destination mounted, when you are doing kubeadm reset, it will automatically unmount it, which will create workload issues. So what you need to do, you need to remount the directory whenever you are making call to kubeadm reset operations. So depending on what is the issue, you have to go and you have to communicate with the right provider who can provide you support in order to come out of these issues. Keep the logs handy, as well as in case if problem is there because of configuration, correct those issues retry, and if it is still not working, try to diagnose deeper. In this video, we'll demonstrate steps that need to be adopted to troubleshoot pod failure crash loop back-off scenario. Now let's go ahead and get a pod whose status is crash loop back-off. In order to do that, we'll write kubectl followed by space get followed by space pods and we'll press enter. Once you'll press enter, you'll find one of the pods to be in status crash loop back-off. And this is the pod which we have to troubleshoot. To troubleshoot this particular pod, we will first describe the pod to get more information. Let's do it. To do it, we'll write kubectl followed by space followed by describe followed by space followed by pod. We'll give a space and then we'll specify name of the pod. Name of the pod is pod v1710. We'll press enter. Once we'll press enter, we'll get certain details where it will show HTTP probe failed with status 500, and since it failed, your kubelet backoff restarting failed container. It may be because you're pointing to a wrong endpoint in order to do the probe. Now, what is the most important unit in the current output which you need to visualize? It's the events, where it first generated warning, reason was unhealthy, and then failed, telling that HTTP probe failed with status code 500, and 500 indicates server issue. You can notify this to the service builder who has to go and tune the service. Now, there are other steps as well which you can take in order to identify the root cause. Now, since we have already identified, but still let's go and see what if we are not able to establish the actual reason. To do that, we'll clear the screen. After clearing the screen, we'll write kubectl followed by space logs followed by space name of the pod followed by space name of the container, and we'll press enter. Once you'll press enter, if there are some logs available, you'll be able to get it. And finally, we need to also go and look at liveness probe, which we have done in the previous step. So these are some of the steps that you can follow in order to capture the actual reason of crash loop backoff and do the needful. In this video, you'll recognize the critical errors in the configuration of Kubernetes resources along with the common error messages that helps troubleshoot configuration issues and eliminate errors. Now let's first go ahead and list critical errors in Kubernetes. These are frequently encountered by administrators as well as other stakeholders who are using Kubernetes. First error is related to invalid images. When you use wrong image in a pod declaration, it can prevent entire deployment from completing successfully. Second critical error is insufficient resources. Your Kubernetes will try its best to schedule pods in a way that it optimizes CPU and RAM usage. But once a resource is exhausted across the cluster, nodes can start to become unstable, and you'll find that new pods can no longer be deployed. Third is operational errors. Now assume that you have a successful deployment, but it does not always mean that your application will also work properly. Errors can still occur even after successful deployment is completed. These errors will occur within pods and they are recorded in the respective pod log files. So you need to go there and identify them. Then comes application errors. Kubernetes automatically collects logs that containerized applications prints to std out and std err. Every event is logged to a pod specific file. You need to access it by using kubectl logs command. Then comes network access error. Kubernetes internally uses a very powerful overlay network with its own DNS service, which can be core DNS or kubedns. It also automatically assigns pod a DNS record which is based on their name and the namespace where they are created. Network access error comes frequently because your container networking interface is not configured properly and there are some issues in your DNS service. And finally, poor node health. Since Kubernetes has a built-in API for monitoring node, which is called as node problem detector, it will deploy a pod to each node that scans the node's kernel log for new events. And when it will have conditions like resource exhausted, health of your node will become poor. So try to avoid those situations. Now let's try to understand some of the common error messages. First error message that you may get is server was unable to return a response in the time allotted. Error syncing pod. Pull image from image service failed. There are various reasons for each of these error messages. Name error, where name XXX is not defined. Or error getting metrics from DNS MASQ. Now, these are some of the common error messages which needs deep analysis of logs in order to identify the actual cause of error. Now, how do we troubleshoot? In order to troubleshoot, we need to check all the critical resources. We need to identify error messages and try to interpret it, and then adopt a troubleshooting approach, where you need to analyze kube-system containers, metadata, and logs. You need to get kubelet status and journal. That will help you to understand what is going on in communication. And third, get etcd status and journal. Apart from this, there are two other activities that you can do. Get your Docker status and journal if you are using Docker as a container. Else, adopt approach in order to get status of your container. And finally, generate and analyze kube-system snapshot. So these are some of the troubleshooting techniques that you can adopt in order to identify the error that you plan to eliminate. And finally, what we need to do in order to eliminate Kubernetes errors. Investigate cluster and application logs. Set appropriate pod resource limits when you are configuring your manifest files or when you are creating a Kubernetes object. Ensure that you have justified number of replica sets that you are creating. In short, set appropriate replica sets. And finally, if needed, increase cluster's capacity. Apart from certain investigations that we have discussed in previous slide, there are various other elements that you need to work with to eliminate Kubernetes errors. And that is check DNS service. Perform health check frequently. That can be done using Sidecar or by adding cache. You need to also ensure that you are scanning node kernel's log frequently to intercept new incoming events, and if those events are creating issues, try to understand the root cause. So by understanding the error messages, you'll be able to identify the component which is in trouble, do proper investigation, and adopt a strategy to eliminate the error. In this video, we'll recall the critical issues that forces a pod to remain stuck in a pending state, resulting in unschedulable pod along with the recommendations that can help us to avoid such critical issues. Now let's try to identify why a pod goes to a pending state. We call a pod as a pending pod when a pod is stuck in pending, means it cannot be scheduled onto a particular node. It is because of insufficient resources of one type or other that prevents scheduler to schedule it. Now, how do we intercept it? We'll be able to discover pending pods by analyzing the messages which is entered by scheduler for its unscheduled pods. We need to also understand that reason can include insufficient resources and use of host port. Now, how do we troubleshoot insufficient resource issues which may result in an issue where your pod is pending to be scheduled to a node? First, we can try adding more nodes to the cluster. Second, try cleaning off your existing node by terminating unneeded pods to make room for pending pods. And third, check that the pod is not larger than your nodes. What if scenario is because of host port? Let's try to understand troubleshooting use of host port issue. In most cases, you'll find that host port is unnecessary. So try using a service object to expose pod. And finally, schedule as many pods as there are nodes in the container cluster when you need host port. By adopting these different approach where you're binding a pod to host port, there are limited number of places that the pod can be scheduled. Be careful and ensure that you are not moving into pod pending issue because of host port. In this video, we'll troubleshoot Kubernetes service issues when the service is using a different namespace or it is simply not available. It's all about finding out availability of a service. Now let's try to understand that whenever issues are coming frequently for new installation of Kubernetes, it may be because services are not working properly. In order to do a thorough check on services, you can take some sample pods, run it, create a service, and then apply your tests. Sometimes what happens, you may have your pods running through a deployment and it might have created a service, but you get no response whenever you try to access it. Let's try to understand some of the approach using which we can manage that situation. And to do that, let's simply run an interactive pod. To run an interactive pod, at the command prompt, we'll be using kubectl, followed by space run, followed by space dash it, followed by space dash dash rm, followed by space dash dash restart. In order to set restart policy equal to never, we'll set it to never, followed by space alpine, followed by space, we'll specify now the image. You will have a popular image called as alpine which can be used for testing. We are specifying dash dash image equal to alpine followed by space sh. Now we'll press enter. Once we'll press enter, we'll be there in the shell of current container which has started. Now let's go ahead and create a deployment which should internally run some pods. To do that, first we'll come out of the current shell by pressing exit. Once we'll press exit, alpine will be deleted automatically. Now let's go ahead and create a deployment. To do that, we'll write kubectl followed by space, followed by create, followed by space, followed by deployment, followed by space. We can give a name to the deployment. We'll say test deployment, followed by space dash dash image equal to, let's take an arbitrary image. After specifying the details, we'll press enter. Once you'll press enter, you'll find that it creates the deployment and kubectl command prints the type and the name of the resource that we have created. Now let's try to scale the deployment. To scale the deployment, we'll be using kubectl followed by space scale, followed by space deployment, followed by space name of the deployment, which is test deployment, followed by space dash dash replicas equal to 3. You can do the same task by creating a manifest file as well. For now, we'll press enter. Once you'll press enter, you'll find that it has been scaled. Now internally, label app is automatically set by your kubectl create deployment and name will be similar to name of the deployment. Now let's go ahead and confirm that pods are running. To do that, we'll write kubectl followed by space get, followed by space pods, followed by space dash l, followed by space app equal to test deployment, which is the label created automatically because of previous commands. We'll press enter. Once you'll press enter, you'll find the status of the image. Status is image pull back off and error image pull because the image that you have specified is not available. So by analyzing the status, you'll be able to know where issue is. Similarly, if you have created your deployment in some namespace and if you are trying to locate it, you may not get it because you are not referring to the right namespace. So depending on your need, you can troubleshoot Kubernetes service
by specifying various different commands which are provided in order to do analysis on existing resources and track the write status and plan accordingly.
In this video, we'll describe the steps that can be adopted to dig deep and investigate every component of Kubernetes cluster to identify scenarios and root causes of problem along with the recommended actions for mitigating and resolving such issues. You don't have any fixed rule in order to plan your troubleshooting. It heavily depends on where that error is, what is the root cause, what is impact of it on rest of the systems, and then you'll be able to adopt the right direction of troubleshooting. Let's go through certain root causes for cluster failure mode. First, your VM itself is shut down. Second, you have network partition within the cluster or between clusters and users. Third, your Kubernetes software itself has crashed. Fourth, data loss or unavailability of persistent storage. For example, you are trying to utilize GCE/PD or AWS EBS volume, but they are not available. Operator error, which is caused by misconfiguration of Kubernetes software, application software, or your manifest files. Now let's go through certain critical scenarios of cluster failure. First, your API server VM shut down or API server is crashing. What is the result? Unable to stop, update, or start new pods, services, or even replication controller. Existing pods and services will continue to work normally unless they depend on Kubernetes API. Second is API server backing storage is lost. What is the result? Your API server should fail to come up. Apart from that, you'll find that your kubelet is also not able to reach. And finally, manual recovery or recreation of API server state is required before you go ahead and restart API server. Third is supporting services VM shutdown or crashes. You'll find that currently those are co-located within API server and their unavailability will have similar consequences as API server crashing. Kubernetes has planned that in future these will be replicated as well and may not be co-located. We need to understand that supporting service VMs does not have their own persistent state. And fourth is individual node shutdown, which results in stopping the pods or the nodes. Now we'll go and we'll analyze certain other critical scenarios where first is network partition. This creates a scenario where you'll find that nodes present in partition A will assume that nodes present in partition B are down. What about the second case, kubelet software fault? It may result in crashing kubelet, which will not be able to start new pods on the node. Apart from that, kubelet might delete the pod or not. So there is no certainty. And whenever you are there in this particular scenario, your nodes will be marked unhealthy. Finally, cluster operator error. It results in loss of pod, services, loss of API server backing store, as well as you'll find that users are unable to read the APIs. Now, what is the mitigation action that we can take after understanding certain critical issues that leads to failure? So let's go through failure mitigation actions. We can use infrastructure as a service provider for automatic VM restarting features for infrastructure as a service virtual machines. This will help you to avoid crashes because immediately another node will be spinned up. You can also use infrastructure as a service provider who provides reliable storage for VMs with API server and etcd. Third, use high availability configuration, which may be costly, but it may lead to decreased failures. And fourth is snapshot your API server PDs or EBS volumes periodically. Apart from this, there are two other actions that you can take which are applicable on cluster objects. First, use replication controller and services in front of pods. and focus on application design so that it can tolerate any unexpected restarts. So by adopting the right mechanism, you'll be able to identify the root cause of issues and impact. If it is failure, follow a process to go through the logs and identify appropriate reason so that you can mitigate those failures with appropriate actions.
In this video, we'll demonstrate end-to-end diagnosis and troubleshooting steps that need to be used to investigate, track, and fix issues of pod and services. It's all about debugging your cluster and troubleshooting it. Now, there are various different reasons because of which your cluster may move to unstable state. First task that you need to do is to check whether your cluster has all the nodes registered and their status is fine. To do that, at the command prompt, you will write kubectl followed by space, followed by get, followed by space, followed by nodes, and you'll press enter. Once you'll press enter, it will show you all the nodes which are present. If you find roles none, it indicates that it's worker. Status is ready. It means your cluster is healthy. Now, in case if your cluster is not healthy and you want further information, you can create a cluster dump. To do that, you'll write kubectl followed by space cluster dash info followed by space dump, and you'll press enter. Once you'll press enter, it will show you complete information along with every small activity that has happened in the cluster. For now, we'll not analyze the log, but you can take a dump in an external file and analyze it. Now we'll clear the screen. After clearing the screen, our next objective is to dig deeper into cluster to know what actually is happening inside. And we will now segregate it into multiple different blocks. We need to analyze the log files. Master log files are essential, so we'll go and we'll see where all log files are present and what all are the critical entries in those log files. First log file that we will open is related to API server. Now let's go ahead and use journalctl in order to see the details of the log entries. To do that, at the prompt we'll write journalctl followed by space dash l followed by space dash u followed by space cube dash API server. We'll press enter. Once you'll press enter, it will show you details of the logs if there are there any. For now, there is no entry, so it is saying no entries. Similarly, we can use the same command, journalctl space dash l space dash u, and we'll give a space and we'll write kubelet. We'll press enter. Once you'll press enter, you will get the log entries which are made by kubelet service. So depending on your need and type of operating system on which you have installed your Kubernetes, either you go and locate the log files in /var/log, or you use journalctl in order to look into the log so that you are able to identify the root cause. There are certain root causes for your cluster failure. First is VM shutdown. You can also have a situation where there are crashes in Kubernetes software. You may also have certain operator errors, which typically indicates that there are certain misconfigurations that has been done in Kubernetes or even application softwares. When we talk about specific scenarios, you'll find sometimes API server backing storage is lost, and that results in API server failure. Similarly, you can have various different critical scenarios for which you need to identify appropriate mitigation strategy. So by following appropriate approach to get details about your cluster, which includes all different components of cluster and the deployments that are done in cluster, you'll be able to identify the root cause and fix the root cause in order to troubleshoot your cluster. So in this course, we have examined how to troubleshoot Kubernetes service issues, perform end-to-end diagnosis, investigate, track, and fix issues of pod and services. We did so by exploring the Kubernetes components that we need to investigate to plan Kubernetes troubleshooting and the commands that we can use to troubleshoot components of Kubernetes cluster. The techniques for troubleshooting issues with etcd database, The steps involved in troubleshooting common failure scenarios while installing or running kubeadm, and how to troubleshoot pod failure crash loopback off scenario. How to troubleshoot the critical issues that forces a pod to remain stuck in a pending state, and how to troubleshoot Kubernetes service issues. The steps that we can adopt to investigate every component of Kubernetes cluster and identify root causes of problems. How to perform end-to-end diagnosis and investigate, track and fix issues of pod and services. In the next course, we will learn to troubleshoot Kubernetes deployments and networking. In this video, we'll identify general principles applied while debugging Kubernetes application, common issues, and describe Kubernetes built-in mechanism to debug applications. As an administrator, we need to be careful and we need to adopt the right approach to start our debugging task. Now let's try to understand certain common issues in Kubernetes that need to be debugged. First is incorrect resource limits. Now, when your resource limits are set too high and a Kubernetes cluster does not have enough capacity in terms of resources, your applications can't be scheduled on the node. It means it will always stay in pending phase. Second common issue is failing liveness and readiness probes. A liveness probe is an essential part of self-healing mechanism in Kubernetes. Now, if your liveness probe fails for some reason, Kubernetes will never restart your pod until it becomes healthy. Third is networking issues. Now, when you are managing Kubernetes cluster, you need to focus on container networking interface, which is a critical component to implement container-to-container, pod-to-pod networks. Then comes 4, role-based access control issues. When you configure role-based access control mechanism, which is enabled by default in Kubernetes, your applications must use a service account with fine-grained role assigned to them. If they are not, you'll find that application access becomes a problem. And finally, misconfigured and constrained pod security policies. When your application requires specific permissions, for example, to access host volume or networking, pod security policy comes into play. So if you will improperly configure those policies, they may restrict applications to start. Now let's try to understand what all are the built-in mechanisms to debug applications in Kubernetes. First, look at Kubernetes events. Second, Kubernetes provides built-in mechanism for debugging pods and containers as well as debugging networking. Now, how do we debug pod and containers? We debug pod and container by using containers log, which provides essential information about activities that are going on inside container. Second is identify pod phases and what all is going on in those phases. Third, look at liveness and readiness probes and their health. And finally, confirm your resource limits and quotas. Now, in order to debug pods and containers, we may use two different approaches. First, we can get a shell to a running container and then go ahead and troubleshoot issues. Second approach is to use Sidecar's container and shared process namespace. In order to debug networking, we need to follow appropriate policy because it's hard to troubleshoot and debug Kubernetes networking issues. You need good understanding of OSI layer, SDN, as well as operating system. And finally, Kubernetes supports multiple different container network interfaces with different capabilities. That also makes debugging difficult. As an administrator, you need to have a plan to debug various different components, keep track of common known issues, and always have troubleshooting mechanism ready for them. In this video, we'll update existing configuration and configure replication controller to ensure that a pod or a homogeneous set of pods is always up and available. Let's go ahead and create a config file and configure replication controller to ensure that you always have a specified number of pod replicas running at any one time. And this will help us to ensure that we have a homogeneous set of pods which is always available. To do that, we'll be creating a configuration file. We'll write vi followed by space name of the file. After writing name of the file, we'll press enter. Once we press enter, we need to write certain statements. Now, instead of using deployments, replica sets, jobs, or daemon set, we are using replication controller. But yes, we need to understand one fact. Given a choice, we should go with deployment. We are specifying API version to be v1, kind to be replication controller. Metadata has name that we have used in order to give a name to our replication controller. It is nginx rc. Then we are specifying spec where replicas we are giving as 3. Selector we are using key value where key is app and value is nginx rc. In templates metadata we are giving name followed by labels. It's the same label that we have specified in selector. And then comes specification for container where we are using container's name, which is again nginx rc in our case, and image is nginx rc. Let's go and give a valid image for nginx. To do that, we'll specify nginx instead of giving nginx rc. Let's keep container port as 90, which is specified below ports. After writing the file, we'll save and we'll exit. To do that, we'll press escape followed by :wq. Now we are out of the file. Our next objective is to run the command that helps us to create replication controller. To do that, we'll write kubectl followed by space apply followed by space -f followed by space name of the file, which is c19 underscore v3 .yml in our case. We'll press enter. Once you press enter, you'll find that replication controller is created. You can check the status of replication controller by using kubectl describe command. Let's go ahead and do it. We'll write kubectl followed by space describe followed by space replication controllers followed by / name of the replication controller, which is nginx rc. We'll press enter. Once you'll press enter, you'll be able to see what are the current set of events which are fired. Now let's go ahead and list all the pods that belongs to the replication controller in a machine readable format. And to do that, first we'll clear the screen. After clearing the screen, we need to write a command. And in that command, we'll be using label selector, and label selector that we have specified is with the command which starts with pods equal to $ followed by opening and closing brackets, and within opening and closing brackets we have used command that is kubectl followed by space get followed by space pods followed by space -- selector equal to app equal to nginx rc followed by space, and then we are deciding what should be the format of the output. Format of the output that we are specifying is by using -- output equal to JSON path equal to within curly braces we are using .items .metadata .name followed by closing of the curly braces and finally closing the bracket. We'll press enter. Once we'll press enter, you'll have a variable called pods initialized with the value that we will get as a result of kubectl space get space pods. Let's go and write echo followed by space followed by $pods. After writing the command, we'll press enter. Once you'll press enter, you will get the pods which belongs to the current replication controller. This is how you'll be able to update an existing configuration file where you might have used deployment and configure replication controller to ensure that a pod or a homogeneous set of pods are always up and available. In this video, we'll update existing deployment to ensure deployment uses updated version of web server that hosts application. We are assuming that you are using nginx web server where you have hosted your static application. Let's go ahead and describe the deployment and see what version of Nginx web server is being used. To do that, we'll write kubectl followed by space describe followed by space deployment followed by space name of the deployment. You need to ensure that you have this deployment already done. After writing the command, we'll press enter. Once you press enter, it will show you various different properties and attributes of your current deployment. We'll go to containers and we'll find that container is using Nginx of version 1.14.2. And this particular Nginx version is hosting our application. Now we want to change the version. To change the version, we need to understand that deployment rollout will get triggered if deployment pod template is changed. For example, if you are changing the label or you are changing the container image of the templates, they are updated. Other updates like scaling the deployment will not trigger when you roll out. Now let's go ahead and update the Nginx pod to use the recent version of Nginx. To do that, we'll clear the screen. After clearing the screen, we'll write kubectl followed by space -- record followed by space deployment dot apps / kubernetes -nginx. Now you need to use set, which you will do after giving a space, followed by space image, followed by space deployment .v1 .apps / name of the deployment. After specifying name of the deployment, we'll take Nginx, which is the label for the container, and we'll use equal to nginx : latest. After writing the command, we'll press enter. Once you'll press enter, you'll get a message indicating that your deployment.apps / kubernetes -nginx, which is the name of the deployment, image is updated. This is how you'll be able to update a deployment. Now let's go ahead and see the rollout status. To see the rollout status, we'll write kubectl followed by space rollout followed by space status followed by space deployment .v1 .apps / name of the deployment. In our case, it is kubernetes -nginx. We'll press enter. Once you'll press enter, you will get a message that indicates that kubernetes -nginx has been successfully rolled out. In certain cases, you may get message that indicates that it is still waiting for rollout to finish, specifically when you have more number of replicas. Now let's go and try to get detail of our deployment and ensure that it is updated. To do that, we'll write kubectl followed by space describe followed by space deployment followed by space name of the deployment. After writing the command, we'll press enter. Once you'll press enter, you need to go to containers and you'll find that your Nginx image has been updated to Nginx : latest. This is how you can update existing deployment to ensure deployment uses updated version of web server that hosts your applications. In this video, we'll apply new configuration file to increase number of pods in current deployment to scale up the application and manage loads. Now, there are various different ways in which you can manage. You can use a command called kubectl scale, which will automatically apply the changes required in your configuration and increase the number of replicas that will help to manage the load. Let's go ahead and see existing replica sets. To do that, we'll write kubectl followed by space followed by get followed by space followed by rs. We'll press enter. And you'll find various different replica sets. Now let's go ahead with nginx -sample. Its current number is 3 and all 3 are ready. Now assume that we want to scale the application which is being managed by nginx -sample. To do that, we'll write a command that starts with kubectl followed by space followed by scale. After specifying scale, we'll give a space and we'll tell deployment because our controller is deployment. After specifying controller, which is deployment in current case, we'll give a space and we'll specify the name, which is nginx -sample. After specifying the name, We'll give a space, we'll write dash dash replicas and assume that we want to increase the replicas to take the load of application to 5. Followed by space, we'll specify 5 and we'll press enter. Once you'll press enter, you'll get a message that your deployment, whose name is nginx-sample, has been scaled. Let's go and execute kubectl space get space rs once again. After writing the command, we'll press enter, and once you'll press enter, you'll find that your nginx-sample alphanumeric number to identify the replicas has been increased to 5, and all 5 are ready to serve in order to balance the load which will be there on your application. This is how you can apply new configuration to increase number of pods in current deployment to scale up the application and manage load. In this video, we'll demonstrate steps to gracefully delete pods which are part of a stateful set without violating inherent stateful set properties. We need to know that in normal circumstances, when we operate on stateful set, there is never need to force delete a stateful pod, because you will have stateful controller who will take responsibility of creating, scaling, as well as deleting members of stateful set. It tries to ensure that always a specified number of pods are alive and they are ready. In short, stateful set ensures that at any time there is at most one pod with the given identity running in cluster in healthy state. Sometimes we need to delete pods. To delete pods, first we'll go and describe pods so that we can locate what pods are running. To do that, we'll go and we'll write kubectl space describe space deployment space nginx-sample. We'll press enter. Once you'll press enter, it will show you detail. Now we want to get all the pods of current deployment. To do that, we will locate label, which is app equal to nginx. We'll retain the label, clear the screen, and we'll try to locate all the pods that have that particular label. You can follow similar steps in order to get pods of various other objects, including replica controller and stateful set. We'll write kubectl followed by space get followed by space pods followed by space dash dash selector equal to app equal to nginx. We press enter. Once you'll press enter, you'll find all the pods that matches that particular label. Now we want to do graceful delete. In order to perform graceful pod deletion, we have to use a command where we have to specify grace period. The practice of setting a grace period to 0 is unsafe, and it is strongly discouraged to be used specifically for stateful set. Graceful deletion is safe and will ensure that the pods will shut down gracefully before kubelet deletes the name from API server. So let's go ahead and invoke the command for graceful shutdown. To do that, we'll be writing a command that starts with kubectl followed by space delete followed by space pods followed by space name of one of the pods. After specifying name of the pod, we will ensure that we are not using dash dash grace dash period to be 0 along with dash dash force. We need to just press enter. Once you'll press enter, your pod will get deleted, and that deletion will be graceful deletion. So it is recommended good practice to ensure that pod should enter to unknown or terminating state only when the user attempts graceful deletion of a pod on an unreachable node. And this is how Kubernetes ensures that your pods are not deleted only because node is unreachable. In case if you want to remove pod in those scenarios, you need to delete the node object, or you can wait for node object is deleted. So depending on the need, you can decide what approach works best to manage deletion of pods. In this video, we'll describe configuration required to manage out-of-resource scenarios where resources are exhausted and makes nodes unstable. You need to always keep track of when to scale up. And one of the scenario is when your resources are exhausted on particular nodes. So let's try to understand certain mechanisms which can be used in order to manage out of resource scenarios. And we'll start with approach of resource handling with kubelet. Kubelet always preserves node stability during low compute resources. Apart from that, it also helps to deal with memory or disk space and provides approach to ensure that nodes becomes unstable if resources are exhausted. And this is the indication where you need to plan your scalability. Now let's try to understand eviction signals, because Kubernetes kubelet supports eviction decisions which are based on certain signals. Let's try to list those signals along with brief description. And that we will do using a table which is currently displayed on the screen. First eviction signal is memory.available, which means memory.available is equal to node.status.capacity of memory minus node.stats.memory.working-set. Then comes node.fs.available, which is equated using node.fs.available equal to node.stats.fs.available. Then comes the third one, which is node.fs.inodes-free, which is equated using node.fs.inodes-free equal to node.stats.fs.inodes-free. Then you have image.fs.available, which is available using image.fs.available equal to node.stats.runtime.imagefs.available. And finally, image.fs.inodes-free, which is equated using image.fs.inodes-free equal to node.stats.runtime.imagefs.inodes-free. So these are various eviction signals along with how they are evaluated. Now let's try to focus on eviction thresholds. Kubelet provides the capability to specify eviction threshold. Eviction threshold will trigger kubelet to reclaim resources whatever are possible. And third essential element that we need to understand is eviction dash signal applied on operator with a particular quantity is the form of each threshold that need to be computed. And finally, let's try to focus on node conditions. There are two critical node conditions which need to be understood from perspective of eviction signal. First, node condition, as it is displayed in the table currently available on screen, is memory pressure. Eviction signal that impacts it is memory.available. We need to understand that it is all about available memory on the node has satisfied an eviction threshold. Second node condition is disk pressure. There are various different eviction signals. First is node.fs.available. Second is node.fs.inodes-free. Third is image.fs.available or image.fs.inodes-free. It is all about how much available disk space and inodes on either the node's root file system or image file system has successfully satisfied an eviction threshold. So by going through eviction thresholds and understanding how kubelet internally manages resources, we'll be able to understand when we need to step in to scale our overall cluster. In this video, we'll create a simple pod to use as a test environment and demonstrate steps of diagnosing DNS problems. Now, one of the critical problems that we may face is related to DNS. Typically, when you are in multi-node cluster, you'll have your cluster which must be configured to use core DNS add-ons or even kubedns. Now we'll demonstrate how to create a simple pod that can be used as a test environment. And to do that, we have to write a configuration file using our editor. We are using VI editor, so we'll write VI followed by space name of the file. After specifying name of the file, we'll press enter. And once we press enter, we have to write certain configuration steps where API version should be v1, kind should be pod, metadata again, it should specify a name to your pod. Current pod name is test DNS utils. Then we'll specify the namespace as well, followed by spec, where we are specifying containers and we are using name as test DNS utils. using image which is provided by Kubernetes for end-to-end test of images, and it is present in gcr.io/kubernetes-e2e-test-images/dns-utils:1.3. We need to invoke some commands. Commands that we are invoking as sleep for 3600 milliseconds, followed by image pull policy, which is if not present, and restart policy is set to always. After creating the configuration file to generate a pod that can be used as test environment to test DNS, we'll press escape followed by :WQ in order to save and exit. Next, we have to create a pod, and to do that, we'll write kubectl followed by space apply followed by space -f followed by space name of the file, which is c19_v8.yml in our case. After writing name of the file, we'll press enter. Once you'll press enter, you'll find that you have created a pod and name of the pod is test DNS utils. Now, once the pod is running, we can execute ns lookup in the environment. Let's go ahead and do it. To do that, we'll write kubectl followed by space exec followed by space -i followed by space -t followed by space name of the pod, which is test DNS utils. After specifying name of the pod, we'll give a space. We'll specify -- space followed by ns lookup. After specifying ns lookup, we'll go ahead and give a space and write kubernetes.default. After writing the command, we'll press enter. Once you'll press enter, it will conduct the check and assume that you are getting an error code. Now, since we want to use this util to diagnose, let's go ahead and use our first diagnose command, which is checking the local DNS configuration. To do that, we'll use the command that starts with kubectl followed by space exec followed by space -ti followed by space test DNS utils followed by space -- followed by space cat followed by space and name of the file, which is /etc/resolve.conf. After writing the file name, we'll press enter. Once you'll press enter, it will give you certain details, where it gives you c2.internal, which indicates that it is using internal DNS. Now, if you have configured a DNS service, it will display name server along with the IP. This is how you will be able to get the details of DNS problem, catch the root cause, and do the needful in order to ensure that you are able to diagnose DNS problems. In this video, we'll investigate problems which are related to execution of init containers, and that we will do by accessing logs to analyze the status. Now, let's go ahead and first get the list of pods which are there. To do that, we'll write kubectl followed by space get followed by space pods, and we'll press enter. Once you'll press enter, you'll find various different pods which are already there. Now we have a pod called init-demo, which is created in order to check the status of init containers. Once we track the pod name, we'll clear the screen. After clearing the screen, we'll use command called kubectl followed by space get followed by space pod followed by space init-demo, and we'll press enter. Once you'll press enter, you'll find that you have init-demo running. Now let's go ahead and describe the pod. To describe the pod, we'll write kubectl followed by space describe followed by space pod followed by space name of the pod, which is init-demo. We'll press enter. Once you'll press enter, you'll find certain entries. Let's try to scroll the entry and go to init containers section, where we have logs called install, which gives us container ID. Along with that, you will also find the state. What is the current state, when it started, when it finished. And finally, you'll come down and you will evaluate various different events. We'll see type of events, what is the reason,
what is the age, from, and message. You can see the events and what events has been doing and identify in case if there is any event that indicates that your init container has failed to execute. If it has failed to execute, you have to debug init container in order to bring it back to healthy state. This is how you can investigate problems related to execution of init container by accessing logs to analyze the status. In this video, we'll list critical networking issues that are encountered with Kubernetes across a variety of deployments. Managing network is complex, specifically because you have various different architectures of network, and Kubernetes supports various different container networking interfaces. Let's try to understand some of the critical networking problems. First problem that we may face is highly coupled container to container communication. Second problem may arise when we try to communicate from pod to pod. Third problem where we need to be careful is those problems which may arise when we do pod to service communication. And finally, fourth kind of communication that we will wish to do is external to service. We need to identify all the critical issues that may be raised when we are trying to build different type of network communication in Kubernetes. In order to identify what's happening in network, we need to understand Kubernetes networking model, where there are certain facts which we need to capture. First fact is every pod gets its own IP address. This means you do not need to explicitly create links between pods, and you almost never need to deal with mapping container ports to host ports. Kubernetes network model adopts a clean and backward compatible model. And finally, in Kubernetes, we can treat pods as VMs or physical hosts. Now, how do we implement Kubernetes networking model? It can be implemented using various different container networking interfaces. First is ACI, which is Cisco application-centric infrastructure that offers an integrated overlay as well as underlay SDN solution that supports containers as well. Second is AWS VPC CNI for Kubernetes. It offers integrated AWS VPC networking for Kubernetes cluster. Third is Azure CNI for Kubernetes. It's an open source plugin which integrates Kubernetes pods with Azure Virtual Network, also called as VNet. Then comes Big Cloud Fabric. It's a cloud-native networking architecture specifically designed to run Kubernetes in private cloud as well as on-premise environments. And then comes Calico, which is an open-source networking and security solution specifically made for containers, virtual machines, as well as native host-based workloads. Apart from that, let's go ahead and discuss about three Kubernetes networking model providers. First is Google Compute Engine. It provides advanced routing that can be used to assign each VM a subnet. Apart from that, it also provides a Linux bridge which is configured to exist on subnet and is passed to containers. Then you have Kube-OVN, which is OVN-based Kubernetes networking fabrics specifically used for enterprises. It provides overlay network features like subnet, static IP allocation, traffic monitoring, as well as service proxy. And finally, we have Kube-Router. It's a purpose-built networking solution for Kubernetes whose objective is to provide high performance and operational simplicity. It can also be used for pod-to-pod networking with no overlay and IP table-based network policy enforcer. So depending on your need, you have to ensure that you are able to adopt right Kubernetes networking model by selecting right Kubernetes networking interface. In this video, we'll demonstrate some of the generic troubleshooting steps and commands that helps to identify
the potential network issues. Now, our objective should be to validate networking related details. For example, we have to validate address, we have to validate node addressing, we have to validate pod addressing, as well as load balancing. Let's go ahead and demonstrate use of certain commands that helps us to validate node addressing and pod addressing, that helps us to identify the root cause in case if there is some issue, and then adopt a troubleshooting approach. To do that, we'll be using a command, and objective of that command is to ensure that we are able to get the addressing scheme of nodes. Let's go and write kubectl at the master, followed by space get, followed by space nodes, and press enter. You'll come to know what all nodes are there which are part of current cluster. You can select any one of the worker node. After selecting any one of the worker node, you need to write a command in order to validate addressing that is adopted by a node. To do that, we'll write kubectl followed by space get, followed by space nodes, followed by space IP-172-31-50-46, because we have selected this particular node and we are specifying name of the node. Followed by space -o, followed by space go-template, followed by space, we'll use --template and we'll pass template which is written using go specification. As per the specification, we are using single quotes, and within single quotes, we'll write 3 statements. Each statement will be specified in double curly braces. Our first statement is range followed by space .spec followed by .podcidrs. We are closing the curly braces. Again, we are writing printf statement within double curly braces followed by space followed by double quotes. Within double quotes, we are using the formatter which is %s/n for new line, followed by space dot, and finally within double curly braces we are writing end. This is what is the template that will get executed and gets us the detail of addressing scheme. We'll press enter. Once you'll press enter, you may have output in 2 different forms. First, you may have IPv4 block, and you may also get an output that has IP4 block as well as IPv6 block allocated. After validating the node addressing, we'll validate that the node has IPv4 interface detected. In the current example, we'll be using the same node that we have used in the previous command. And to do that, we'll write a command that starts with kubectl followed by space get, followed by space nodes, followed by space name of the node, followed by space -o, followed by space go-template, followed by space --template equal to, again within single quotes, we'll specify range followed by space .status.addresses. We'll close the curly braces and start new double curly braces to write another statement where we are writing printf followed by space within double quotes %s colon space followed by %s followed by space /n. We'll close the double quotes. We'll give a space and write .type followed by space .address. We'll close the curly braces and then we'll write end within 2 curly braces. And we need to ensure that all the curly braces and single and double quotes are well balanced. After writing the command, we'll press enter. Once you'll press enter, it will get you the details where it gives internal IP and host name. Now, our next objective is to validate pod addressing. To do that, we'll first clear the screen. After clearing the screen, we'll write kubectl followed by get followed by pods. We'll press enter and we'll select one of the running pods. Assume that we have selected a pod, which is pod v13, and we want to validate pod address. To do that, we'll clear the screen. After clearing the screen, we'll write a command that starts with kubectl followed by space get followed by space pods followed by space pod v13, which is name of the pod, followed by space -o followed by space go-template followed by space --template equal to, within single quotes, we'll write 3 statements. Each statement will be specified in double curly braces. Our first statement is range space dot status dot pod IPS, where IP need to be caps. After closing the curly braces for the current statement, we'll start new double curly braces for next statement, which is printf, followed by space within double quotes %s followed by space /n and closing of double quotes, followed by space dot IP. And we'll ensure that double curly braces are closed using double curly braces. And the third statement is end, which is present within double curly braces. We need to ensure that all the single quotes, double quotes, as well as curly braces are well balanced in the command. After writing the statement, we'll press enter. Once you'll press enter, it will give you IPv4 address of your pod. Now we need to see what is the content of host file which is present in /etc folder of the pod. And to do that, we will execute a command that starts with kubectl followed by space, followed by exec, followed by space -it, followed by space pod v13, followed by space -- followed by space cat, and finally followed by space /etc/hosts. We'll press enter, and you'll find that it gives you detail of host file which is currently managed by Kubernetes. These are some of the steps that you can use in order to explore your networks, find the issues, and start troubleshooting. In this video, we'll demonstrate steps to inspect IP table rules that is used by Kubernetes to implement virtual IP translation and load balancing for service IPs. Kubernetes networking model is complex, and you have various different CNIs that facilitates in order to adopt the right Kubernetes networking model. Now let's go ahead and demonstrate certain steps that can be used to inspect IP table rules. Now before we start, we need to understand that in Kubernetes version 1.11 and earlier, Kubernetes used IP table NAT to implement virtual IP translation and load balancing of service IPs. Now let's go ahead and see how do we dump all IP table rules which are present on a particular node. To do that, we'll be using a command that starts with IP tables, followed by -save, followed by space. We'll just use a pipe in order to control the scroll so that we can see rules one by one, followed by space, followed by more. We'll press enter. Once you'll press enter, you will get the top entry of your IP tables. We can see it is generated by IP tables -save, and it shows what is the output except Kali-output, Kali-pre-routing. You can analyze the log, and in order to get more details, you need to just press enter, locate what you are looking for, and analyze each and every step by identifying target, port, destination, and the route. You'll have lots of information here which will help you to create a dump and then analyze whether a particular IP or port is reachable as per IP table entry or not. Now let's go ahead and try to understand how do we query cluster DNS. We'll first come out of this by pressing Ctrl+C. We'll clear the screen. After clearing the screen, we'll write kubectl followed by space get, followed by space service, followed by space -n, followed by space kube-system, followed by space. Let's try by writing kube-DNS and we'll press enter. Once you'll press enter, it will show you the detail, and you will find that cluster IP of kube-DNS service is 10.96.0.10. It is not still bound to any external IP. We can also see the ports which are being used by kube-DNS. Now once we are aware about it, we'll go ahead and we'll try to look for IPVS details. To do that, at the command prompt, we'll write IPVS ADM followed by space capital L and N. We'll press enter. Once you'll press enter, you'll find that it is not installed. Let's go ahead and install it. To install it, we'll write apt followed by space install followed by space IPVS ADM. Once you'll press enter, it will ask you to continue. We'll press capital Y and press enter. Once you'll press enter, it will start installing the utility. Once it is installed, we'll re-execute the command, which is ipvs adm space dash capital L followed by N. We'll press enter. Once you'll press enter, it will give you the details of IP virtual server, which is being currently used. This is how you'll be able to inspect IP table rules that is used by Kubernetes to implement virtual IP translation as well as load balancing for service IPs. In this video, we'll investigate network Kubernetes ingress and service traffic flows. Now let's try to look at the ingress to make sure that everything is fine, and we'll come to know by first listing all the ingresses that we have. To list all the ingresses, you'll be writing command that starts with kubectl followed by space followed by get followed by space ingress, and you'll press enter. Once you'll press enter, it will show you the name, the host, address, port, and age. In production, when you try it, it will work better because you will have a DNS as well as an address allocated to them. Now let's go and get more details about ingress. And to do that, we'll be writing kubectl followed by space describe followed by space ingress followed by space name of the ingress, which is minimal dash ingress. After writing, we'll press enter. Once you'll press enter, you will come to an interesting entry. You have to look at host followed by path and followed by backend. If you see that backend is showing error, it means that this target is not present. So you need to communicate to your service provider in order to ensure that at the particular host, that particular service is up and running. Now, in case if service is already up and running and you have specified the right host and path, you will get no error there. So you need to indicate to your service provider or service developer to ensure that they have deployed the service which is accessible at the current port. This is how you will be able to investigate network Kubernetes ingress and see the service traffic flow, identify the error, pass on the error to the right stakeholder in order to ensure that externally available services are corrected. Once they are done and deployed, you'll find that your ingress works fine and also manages traffic flow well. So in this course, we have examined how to troubleshoot Kubernetes deployment and networking. We did so by exploring the generic principles that are applied while debugging Kubernetes application, the built-in mechanism provided by Kubernetes to debug application, and the configuration required to manage out-of-resource scenarios. How to update existing deployment to ensure the deployment uses an updated version of web server hosting the application, and how to increase the number of pods in a current deployment to scale up the application and manage load. How to investigate the problems related to the execution of Init containers, Kubernetes network ingress and service traffic flows. How to gracefully delete pods that are part of stateful set and inspect the IP table rules used by Kubernetes to implement virtual IP translation and load balancing for service IPs. How to create and use a simple pod as a test environment to diagnose DNS problems, and how to work with generic troubleshooting steps and commands that can help identify potential network issues. In the next course, we will learn how to troubleshoot and resolve issues associated with GKE and workload deployed on GKE, ingest log into Elasticsearch, and visualize the metrics using Kibana. In this video, we'll recognize the recommended options for customizing Kubernetes cluster and describe how extension points interact with Kubernetes control plane. Kubernetes is extensible, and that extensibility needs customization capabilities of Kubernetes cluster. Now let's try to understand the objective of customization and approaches that can be used in order to customize Kubernetes cluster. Customization's objective is
aimed at cluster operators to adapt Kubernetes cluster to work environment requirements, which may keep changing. There are two different approaches of customization. First, configuration based. Second, adding it as an extension. Now let's try to understand the first approach, which is configuration. Configuration typically involves changing the flags, local configuration files, or API resources. In configuration, flags and configuration files may not always be changeable in hosted Kubernetes service. So you need to build and you need to rehost it. And finally, configuration can be managed only by administrators. In short, only the cluster administrator can make the necessary changes in configuration. Then comes extensions. Extensions are considered as software components which extends and integrates well with Kubernetes. Extensions have to adapt to support new kinds of hardware. And finally, cluster administrators will use a hosted or distributed instance of Kubernetes which is plugged in with extensions. Now let's try to understand a pattern that helps us to extend capabilities of Kubernetes. Kubernetes is designed to be automated by writing client programs. In other words, you can write programs and automate orchestration and capabilities of Kubernetes. Primary role is played by Kubernetes control plane, which will have access to all the Kubernetes nodes. You will have kubelet, and those kubelets will play essential role in order to build the communication. As the diagram on the screen indicates, you will have Kubernetes control plane, which can directly interact with webhook backend. But in order to interact with binary plugin, it needs kubelet. And finally, controller, which is present on Kubernetes node, will place the request to Kubernetes control plane to invoke various different backend services which are part of cluster. So depending on your need, you can plan which approach of customization works well. In this video, we'll demonstrate troubleshooting steps that you might find helpful if you run into problems using Google Kubernetes Engine. Now, we assume that you have already created the cluster. Once you have created the cluster using Google Cloud Platform, you have to go to Kubernetes Engine dashboard. On Kubernetes Engine dashboard, you need to select the cluster and you need to click on it. Once you click on it, you will get details of the cluster. There are three essential elements that will have impact over your cluster. First is general information, where you'll come to know what is the version, what is the endpoint, client certificate, status, binary authorization, master zone, default zone. You will also come to know about pod address ranges. Apart from that, you will come to know default maximum pod per node. So in case if you are getting pod creation failure, you can configure and increase the quota for default maximum pods per node. You will get generic information when you go with details. Second is storage, where you'll come to know what all different types of storages are there. It will list persistent volumes if they are there. It will also show you storage classes. Using kubectl commands and by writing manifest file, you can go ahead and create storage classes as well as persistent volumes. Third is the nodes. When you click on nodes, it will show you details of the nodes along with status, their limits from perspective of CPU and memory, apart from all storage requested and storage allocated. So all the troubleshooting that you will be able to do only after identifying the problem, and you'll be able to identify the problem if status is not ready or if it is in a different state. Now let's go to the left navigation panel and click on configuration. Once you click on configuration, it will show you configuration details of your current cluster. We'll click on default token DNRCF. Once we'll click on it, it will show default token details. This is how you'll be able to know about tokens. Now let's go and click on clusters, which is there on the left navigation panel. Once you click on it, we'll click on the cluster of our choice, which we want to analyze for issues. Once you click on it, it will show you the details. You need to go to the option where it shows cloud operations for GKE. This particular unit is something which will show you system and workload logs and also keep on monitoring your cluster. Now let's go ahead and click on View Logs. Once you click on View Logs, it will open a new tab. And in new tab, it will give you detailed logging dashboard, where it will give you options at the left navigation panel. You have Log Explorer to explore the log. You have Log Dashboard. You have log-based metrics. You have Logs Router. You have Log Storage. Apart from that, it will also facilitate you to query. In order to query, you need to write your query at the current space and run the query. Now, for example, in order to build a query, we can go ahead and we can select resources. Once you click on resource, it will list all the Google Cloud resources. Let's go and write Kubernetes. Once you write few words of Kubernetes, it will show you all resource type. Let's go and select cluster. We'll select clusters, location. After selecting location, it will list clusters which are there in that particular location. We'll select our cluster and click on add. Once you click on add, it will generate a query where it will give details about the current cluster. Now you can click on log names and select the logs that you want to be part of the query. So depending on the component of Kubernetes that you want to visualize to troubleshoot your issues, you'll select them, click on add. Once you click on add, you'll find that it has added those logs also as the data center which will be used by the query. You can select severity. For example, let's go and select critical, alert, and emergency and click on add. After setting up your resource type, log name, and severity, we'll click on Run Query button, which is there at the extreme right on the current panel. Once you'll click on it, it will generate log fields along with histogram. Since there are no logs for the severity that we have selected, it is showing empty. These are the steps that you might find helpful if you run into problems using Google Kubernetes Engine. In this video, we'll demonstrate common troubleshooting steps to fix issues with deployed workloads on Google Kubernetes Engine. Google Kubernetes Engine comes with a dashboard. We have already seen how actually we can troubleshoot Google Kubernetes Engine by getting into logs of Kubernetes. Now our objective is to see what can be done in order to intercept issues with workloads and take corrective measures. To do that, we will launch Kubernetes Engine dashboard on Google Cloud Platform. After launching, you'll get clusters which are already created in your current project. Now we'll click on workloads, which is there at the left navigation panel of Kubernetes Engine. Once you'll click on it, it will show you your workload, status, type, number of pods, namespace in which that particular workload is present, and in which cluster it is deployed. Similarly, you can go ahead and you can click on services and Ingress, which is present at the left navigation panel. Once you click on it, it will show you the details of the services. You have to go ahead and you have to explore all the different components which are there available on Google Kubernetes Engine. You can also visualize configuration, storage, object browser. Apart from that, it also provides you capability to directly migrate to containers. Now let's come back to workloads and click on the workload which is currently deployed in Kubernetes cluster whose name is cluster-1. We'll click on it. Once you'll click on it, it will show you details of the workload. Most important element that you need to look at is the events. So you will go to the events tab and click on it. You'll find that there are no recent matching events because it's a new deployment that is created. Assuming that you have deployments which are in trouble, you can go and you can see the logs by clicking on Logs tab. Once you'll click on Logs tab, it will show you all the container logs of the current deployment. You can go and select a log entry which shows error, click on it, read the error, identify the issue, and take the corrective measure. In case if you want to use conventional kubectl commands, you'll go to the top panel and at the right, just beside actions, you will have a button called as kubectl. We'll click on it. Once you click on it, it provides you options which includes get YML, edit, as well as delete. Let's go and click on get YML. Once you click on get YAML, it will provision your Google Cloud Shell machine and it will launch the command which starts with gcloud space container space cluster space get dash credential space cluster dash 1, which is name of the cluster, space dash dash zone dash us dash central 1 dash c, which is the current zone. Then the project is specified by giving a space dash dash project followed by a space name of the project, and then you'll be concatenating the command by using double ampersand. Command that you will concatenate is kubectl followed by space get followed by space deployment followed by space nginx dash 1 followed by space dash o followed by space YML. After writing the command, we'll press enter. Once you'll press enter, it will ask for authorization. In case if you are not authorized user, you will get into issue and then you have to troubleshoot your cluster. Let's go and click on authorize. Once you click on authorize, you'll find that you already have logged in with a different account. You can go and you can select an already authenticated account to use. Assuming that you are authenticated, we'll clear this. After clearing the screen, we'll write kubectl followed by space get followed by space pods. After writing the command, we'll press enter. Once you'll press enter, it will list the pods which are currently running. Similarly, you can use any kubectl command that helps you to know the current status of workload. So depending on the errors, you can troubleshoot and ensure that your containers, pods, storage are aligned properly and all your services are consumable. These are some of the common troubleshooting steps that you can take in order to manage issues with deployed workloads on Google Kubernetes cluster. In this video, we'll list the log files that are present on the master and worker nodes along with the critical entries that can help identify issues. Tracking log files and content of the log which are created by various different Kubernetes components are important. It helps you to check what is going on internally in the cluster and its components. Now let's go ahead and understand cluster listing. Objective of cluster listing is to check if all the nodes are listed correctly. It runs and verifies that all of the nodes expected to see are present and they are in healthy state. And finally, all the existing nodes should be in ready state to place the pods whenever needed. Then comes master node log files. We need to understand that if your system is systemd based, you may need to use journalctl in order to access kube API server log, kube scheduler log, as well as kube controller manager log. But if you are using non-systemd systems, you will find that log files are present in /var/log directory. There are three critical master node log files that you need to visualize. First is present in /var/log/kube-api server.log. Second is again present in /var/log directory, but name is kube-scheduler.log. And finally, you have kube-controller-manager.log, which is again present in /var/log directory. Now let's try to list essential worker node log files. Kubelet plays important role, and this is the reason why you need to ensure that you keep close eye on kubelet logs. Kubelet logs are present in var/log/kubelet.log, and its responsibility is to log logs created during the lifecycle of running containers on the node. And then you have /var/log/kube-proxy.log. It is responsible to keep logs that are related to service load balancing. So you need to ensure that you have access to write logs so that you can go through the log and identify any activity that may have negative impact on Kubernetes cluster. In this video, we'll set up Kubernetes cluster to ingest logs into Elasticsearch
and view metrics using Kibana. ELK contains three essential components. First is Elasticsearch, which is the database. Second is Logstash, that has capability of probing and pulling the logs. And we have Kibana, which provides visualization capability. In order to ensure that we are able to manage these three objects, we can use Kubernetes, and Kubernetes suggests to create deployment using YAML file and specify the required replicas and the templates in order to get facility of ELK in Kubernetes. Let's go ahead and create the manifest file. To do that, we'll connect to master, we'll write vi followed by space and name of the file. After specifying name of the file, we'll press enter. Once you'll press enter, you have to go and you have to write YAML file. We'll start with API version, which should be apps/v1. Then comes kind, which is deployment, followed by metadata in order to give a name to the deployment, followed by spec, where you are specifying the replicas. We just want one as of now. Selector, match labels, we are specifying stack ELK, where stack is the key and ELK is the value. And within template metadata, we are specifying the same labels that we have specified in match label. Then comes the spec, which is the important one. We are taking containers. We are giving a name to the container as Elasticsearch. Image is Elasticsearch. Port that we are specifying to Elasticsearch is 9200, which is default port for Elasticsearch. Then comes the second container, which is Kibana. We are specifying name as Kibana, image as Kibana, and ports that we are specifying is container port :5601, which is default port for Kibana. Then comes environmental variable configuration, where we are injecting one environmental variable, that is Elasticsearch _ URL, and we are specifying value to be http://localhost: 9200 within double quotes. Then comes the third container, which is Logstash. We are specifying name, followed by image, followed by ports, and we are specifying container port for Logstash to be 8080. Then comes what do we need to execute on Logstash. On Logstash, we'll pass arguments that will get executed, where we are building index for Elasticsearch, and that we are doing by using input, followed by space, curly braces HTTP, followed by opening and closing curly brace, and we are closing the first curly brace as well. Then comes the output, which is within curly braces, where we are specifying Elasticsearch. Again, start of curly brace, where we are specifying hosts with equal to and greater than symbol. We are using localhost: 9200. Inverted commas, curly braces, and square brackets must be balanced. What this command does? This command reads logs from your Kubernetes and it stores it in Elasticsearch with an index. After configuring the file, we'll press escape followed by :WQ to save and exit. Now we are out. After coming out, we'll clear the screen and we'll write the command that starts with kubectl, followed by space apply, followed by space -f, followed by space name of the file. After writing the command, we'll press enter. Once you'll press enter, you'll find that it has created ELK aggregator. We'll write kubectl space get space rs in order to see the replica set. And we'll see that ELK aggregator has one replica set because that is what we have specified. Now let's go ahead and expose the service. To do that, we'll write kubectl, followed by space expose, followed by space deployment / name of the deployment, which is ELK aggregator, and we'll press enter. Once you'll press enter, you'll find that your service is now exposed. Now let's go ahead and see the service. To see the service, we'll write kubectl, followed by space get, followed by space svc, and we'll press enter. Once you'll press enter, you'll find that ELK aggregator has been allocated an IP along with 3 ports that we have specified in configuration file. This is how you can set up a Kubernetes cluster to ingest logs into Elasticsearch and view metrics using Kibana. So in this course, we have examined how to troubleshoot and resolve issues associated with GKE and workload deployed on GKE, ingest logs into Elasticsearch and visualize the metrics using Kibana. We did so by exploring the recommended options for customizing Kubernetes cluster, how the extension point interacts with Kubernetes control plane, and the log files present on the master and worker nodes. How to troubleshoot and resolve issues or problems associated with the use of Google Kubernetes engine. How to troubleshoot and fix issues associated with deployed workloads on Google Kubernetes clusters. How to set up a Kubernetes cluster to ingest logs into Elasticsearch and visualize the metrics using Kibana. And this concludes the certified Kubernetes administrator journey.